session, the awards. I think we had some awards yesterday. We are going to go on with awards today, and this is part of deep learning Indaba's core purpose, to recognize and award some of the people doing excellent work in the continent. And so we're going to kick off today with the award session, the Kambule Awards. And I'm just hoping people who are coming in can come in and settle down. Thank you. Come on in, welcome, so that we can get started. So we're starting off with the Kambule Awards. Does anyone remember who won the Kambule Award last year? Who remembers who won the Kambule Award last year? Okay, what about the year before that? Anybody? Are you all new to the Indaba? Or is it that you don't come to the award ceremony? So this year, next year, if we ask who won the Kambule Award last year, I hope a lot of you are going to remember that name, okay? Does anyone know any Kambule Award recipient? Does anyone know any Turing Award recipient? Okay. All right. That's something we need to work on. All right. One Kambule Award recipient is sitting right here. He was actually the winner of the Kambule Award the first time I attended the Indaba. So that one I never forget, because that was my first Indaba and I got to know the first Kambule Award recipient. Anyways, we're going to go on. So we're going to get started with the Kambule Award. And the Kambule Award, what is this award for? It's awarded for the PhD thesis or dissertation, depending on how you call it, in any area of artificial intelligence and computational and statistical sciences. But who exactly is Kambule? Right? Does anyone know who Kambule is? Probably a lot of you know who Mathai is. There was a Mathai Award that was given, Professor Wangari Mathai. But who is Professor Kambule? I think he was a professor, if I'm not wrong. Right, so I'm gonna read a little bit of his biography. He's one of South Africa's greatest mathematicians and teachers, and is remembered for his life's contribution to education, specifically to black education under the Bantu Education Act, a segregated education system enforced during the apartheid regime. Throughout his teaching, 20 years of which he was the principal of Orlando High School in Soweto, he went on to shape and influence many great minds, including Nobel Prize winner Desmond Tutu. Probably all of you who know who Desmond Tutu is. The former National Police Commissioner, Jackie Selebi, and former Chief Executive Officer of the Independent Electoral Commission, Pansy Kula. I'm really butchering the South African names here, but you're gonna forgive me. He was awarded honorary doctorate degrees from the universities of Witwatersrand, Pretoria, and Fort Hare, and was the University of Witwatersrand's first black professor in mathematics. In 2002, the former South African president, Thabo Mbeki, bestowed him with an Order of the Baobab in the Gold for his exceptional contribution to mathematics, education, human development, and community service. In 2008, he went on to be awarded the honorary membership of the Actuarial Society of South Africa, a membership he was denied during the apartheid. The Kambule Doctoral Dissertation Award is established in honor of his contributions to the field of mathematics and dedication to furthering the minds of his students. So that's Professor Kambule, and therefore today we are at the Indaba very excited to announce the winners of this year's Kambule Doctoral Award. So I'm gonna start with, I don't know if the team is ready here, okay. The runner-up, it's always exciting to announce goodies. What does the runner-up get? They're getting a trip to DLI next year. We don't know where that's gonna be. But they're getting a trip to DLI next year. And they're also getting a $500 award, right? That's the runners-up of the Kambule Doctoral Award. Excellent work. Those of you who have done PhDs know what it takes and what it goes into a PhD. And so, I am very excited to announce the runner-up. It's Dr. Brendan Ingram. And yes, please come on in. Thank you very much. Before you go, I want him to say a few words about this award and himself. And yeah, thank you.
All right, thank you very much, firstly. It's moments like this that definitely reinforce in my mind that this is the place to be. You know, academia, attending Deep Learning Indaba specifically. Of course, I'll thank the awards committee, as well as like the community back at home. For any of you who have done a master's or PhD or who are busy doing that, I'm sure you would agree that all that hard work is very hard to achieve on your own, and everyone leans upon everyone else. So I'd just like to take time to thank everyone I've lent on over the last couple of years. Thank you.
Thank you very much. A round of applause once more for Ingram. Thank you very much, Dr. Ingram. Yes. I wish he could speak a little bit more about his thesis, but we don't have time for this. So, but it's always exciting to read, PhD theses coming out of the continent. And so, now on to the winner of the Kambuli Award. First of all, what does the winner get? By the way, the Kambuli Awards are sponsored by Black in AI. Those of you who know Black in AI, so they are sponsoring these awards that we're mentioning. So yes, the winner of the Doctoral Kambuli Award gets one thing, a trip to DLI next year again. So we're going to have the two of them next year. Please remember their name, okay, next year. When I ask who is the winner of Kambuli Award next year, somebody can mention their names. They also get a $1,000 voucher, and they get a trip to NeuroIPS next year. I am not quite sure where NeuroIPS is next year. Vancouver? Okay, yes. So they also get a trip to NeuroIPS next year. So, who is the winner of this year's doctoral award? And I'm very excited to invite Dr. Irene Nandutu, and that's the winner of the Kambuli Doctoral Award. Thank you very much. Come on in. And so, of course, we would love to hear more about this thesis that won this award. So I would like to welcome Dr. Irene to give a 10-minute max presentation on this. So yeah, Dr. Irene, thank you very much.
Thank you very much and for the nice introductions and for this day. My name is Irene Nandutu. My PhD thesis is entitled Wildlife Vehicle Collusion, Mitigation Measures. My interest is using road ecological data and deep learning. It's supervised by Dr. Marceline Atemkeng and Dr. Patrice Okum. The PhDs are awarded by Rhodes University. Currently, I'm a senior lecturer at Busitema University in Uganda. But immediately after my PhD, I transitioned into a postdoc at the University of Cape Town, where I'm working with Professor Deshane Mondley and Professor Casti Donald on early childhood and AI. So Just to talk about wildlife vehicle collisions, generally amphibians or smaller animals are killed more than large animals. US records around 1.5 million cases to approximately 200 humans dying every year. Canada records around 4 to 8 animals per day. And Tanzania, representing Africa, around 97% of animals are recorded. In South Africa, where my cases applied, in Mpumalanga, they registered around higher wildlife vehicle collisions recorded on paved roads than non-paved roads. And in just 2 fortnights, South Africa in 2012 recorded around 470 wildlife vehicle collisions. So on the continent, it's a very big problem that is happening. Just to set out caution, there is disturbing content, so hope that you do that. So when we talk about wildlife vehicle collisions, what are the impacts that this creates? So if we look at the elephants, these animals sometimes tend to attack people when they go into their habitats. Humans are running over these species on highways and killing them up. If we look at the image with a deer, that gentleman broke their hands and legs. And it also destructs properties on highways, which is very expensive for governments to actually clean up these collision sites. And my work is looking at, if we really see this need, my work is looking at exploring the different mitigation measures that could be applied within the African continent, and basically for the case of South Africa. What does exist so far? So different researchers have done tremendous work to address the issue of wildlife vehicle collisions. From traditional systems, those are underpasses, overpasses, and wildlife fencing, to intelligent systems like break-the-beam sensor, animal detection systems, area cover animal detection systems. But these systems actually in the north. In the ecology and AI generally, you find on the continent, I'll highlight EMS that are doing research in ecology and AI in wildlife, but we don't have yet much that is being paid attention on ecology. In developed economies still we have driverless cars that are actually detecting these systems on highways. But for the African government has highlighted how these systems are expensive. That is the intelligence system to adapt. So what can we do that would work for us? This work I had a discussion with the Endangered Wildlife organization in Joburg. And one of the things that is keenly looking at is there exist ethical concerns within these organizations, and some of them are poaching incidences that happen, and illegal trade on social media, people actually selling products, illegal barriers on drones. If in case, for the case of South Africa, it took me a lot of time to get ethical clearances to be able to fly drones and collect data. So what exists also is a lot of embargoes that you need to look at, but then ecologists are worried on the integration of this into AI system, and my work comes in to propose an ethical framework that integrates AI ethics into AI systems, uses agile technology. If we have all these cases in together, we can be able to attain an ethically AI system. The other is I was looking to analyze the complex animal vehicle collision patterns within highways on South Africa. This work is collected from Endangered Wildlife Trust. If you look at this area is around the Limpopo area in a conservation reserve where they collected data on roadkill cases. And when we look at keenly about, those are the 3 ecological seasons of South Africa: hot, dry, hot, wet, and cold, dry seasons. You realize that there are patterns within those seasons where some animals or taxas are killed more than the others. And these are some of these complexities that I was looking at in my work. So my work came up with a mathematical framework that uses matrix formalism to work with ARIMA family of models. Basically, I later on proposed an error correction framework that looks at understanding the linear and nonlinear components within the data and finding sure that for each time that we have more linear patterns within the data, the hybrid or the error correction framework performed better, and each time that we had more nonlinear components, LSTM worked quite well. The other mitigation measure is looking at the concentration areas. Apart from working with time series, we also went ahead to work with wildlife fencing. Those are the concentration areas that the same data was collected at. Of course, behind any wildlife fence, you find all these components working together to ensure that we don't have animals crossover. And while South Africa has single and double fences, which could mean differently, an electric fence, the motivation of this work is, can we have an AI tool that seamlessly detect wildlife fences with collection of GPS coordinates on highways? And because of this, this is the motivation of this work. What will we use the images that we've detected for? We can retrain them on the model, but also have a dashboard which alerts all drivers of the high concentration areas. The data collection happened on the Eastern Cape of in South Africa, and I worked majorly with Lalibela and Amakara game reserves. Data was collected using drone and still cameras. And I trained the data using different algorithms, but I'll go to the unit. Majorly, data from the drones performed better than still camera devices, and this can be attributed to the resolution that these gadgets do get. They tend to affect a lot the machine learning algorithm. So the contribution within this work is it can be able to recognize fences, but serve as a reliable indicator to inform road users about the presence of animal vehicle collisions, also enhance security and wildlife fence security and wildlife safety. My work attracted publications in peer-reviewed journals that you can find here. I also have a manuscript under review and revision. I'm very grateful to Rhodes University for funding my PhD, Amakala and Ladibera, but the different individuals that are contributing or continue contributing to my career. As a mode of acknowledgement, I want to tell you something that has transpired with me being at Deep Learning in Indaba. Around 2017 was my first time to attend a Deep Learning in Indaba that was generously funded by DeepMind. And within that event is when I was able to meet Dr. Marceline Atemkeng, who was my PhD supervisor. And my master's research also won the MIT Prize Award at that event. Later on, we met at Black in AI, and that is when we had discussions about my PhD. So why am I telling you this? These communities are platforms that you could find people who can impact your career. And I'm very grateful to these all communities for having this contribution towards my career. Thank you so much.
Thank you. Yeah. Thank you very, very much, Dr. Irene. I think if you're ever wondering what's the real world application of AI, I think you saw it yourself, right? That's an incredible thesis, and I am very, very excited and happy that that won the doctoral award. It's excellent work. I just want to go off script here and say something that I said in the profile of Dr. Kambule that I read. The last part of it, what I said was, the Kambule Doctoral Dissertation Award is established in honor of his contributions to the field of mathematics and his dedication to furthering the minds of his students. That last part is very important. Dr. Marcel won the award in 2008, and you can see his student won the award in 2024. What more? Thank you very much, everyone. That's the award session. I hope Dr. Irene's student will be winning the award in 2028 or something like that. So yeah, thank you very much, everyone.
Have happened in over 25 countries in Africa. Indaba X Central Steering Committee presents the Indaba X chapters, locally organized by Indaba, strengthening machine learning on the African continent. The Indaba X events have happened in over 25 countries in Africa since its inception in 2010 until today in 2022. We have had events in our program run successfully in Algeria, Namibia, Cameroon, Nigeria, Egypt, Senegal, South Africa, Ethiopia, Sudan, Ghana, Tanzania, Kenya, Gambia, Lesotho, Togo, Malawi, Tunisia, Mali, Uganda, Mozambique, Zambia, and many other African countries.
The Deep Learning Indaba is, I guess, a movement that we started back in 2017 with the aim of strengthening machine learning in Africa. And we're trying to build communities, to train people, and to highlight some of the fantastic work that's being done in Africa in machine learning and artificial intelligence.
We ran the first Deep Learning Indaba in Johannesburg in 2017, and our original plan was to run a small summer school or series of master classes for maybe 40 students. For the first Deep Learning Indaba, 700 students applied, and it was an inflection point for us as organizers. And at that point we said, let's go big. We can't let 700 students apply and then only accept 40.
So I've seen groups of people coming together to learn without any type of guidance, using only what exists on the internet and building wonderful things out of it.
And in the first year, a large number of countries applied, and I think roughly 12 to 15 Indaba X's were held from across Africa. And so this continued. There's been Indaba X's in almost 30 countries in Africa now, and the community is really flourishing.
I would see, an exponential growth of, AI conversations at the university and across the country, resulting from these Indaba activities. We've also created a platform where students, researchers, enthusiasts.
More than a conference, celebration of excellence, gathering of minds and hearts, a showcase of skills and arts, Indaba X Steering Committee presents the Indaba X Chapters 2023.
The Indaba is a gathering of the African AI community, a place where we all come and meet and share our work and catch up on what people have been up to.
The mission of the Indaba is to strengthen machine learning and AI in Africa. We're building a strong and vibrant and very inclusive community. It's a grassroots movement that's on the way and growing.
Do this by building communities, creating leadership, and recognizing excellence across our continent.
The Indaba X is another program we've started under the Deep Learning Indaba to grow local leadership across the continent
by having a whole lot of different events running in different countries.
36 countries from Algeria to Zimbabwe, from Mali to Madagascar. Each one has its own flavor and character. Algeria, Benin Republic, Burkina Faso, Burundi, Cameroon, Cote d'Ivoire, Djibouti, DR Congo, Egypt, Eswatini, Ethiopia, Gambia, Ghana, Guinea, Kenya, Lesotho, Libya, Madagascar, Malawi, Mali, Mauritius, Morocco, Mozambique, Namibia, Nigeria, Rwanda, Senegal, Somalia, South Africa, Sudan, Tanzania, Congo, Tunisia, Uganda, Zambia, Zimbabwe. We build together.
Good morning, everyone. And so you're welcome to the Research in Africa Showcase Day, where we have quite a number of interesting activities. First, I'll introduce myself. Bruno Sechwere, the team lead for the Indaba X steering committee, and my co-host.
Hello everyone, I am Lesefo. I am the Research and Innovation Lead as part of the Indaba X Central. Okay, so quick announcement, like with all the other days, for the updated program, please scan the QR code. Also check on the Slack channel under the general channel. It should also be available there. And also for the poster sessions, we have updated the schedule. Please make sure that you look at the poster schedule and your corresponding poster number that is available on there.
So at this stage, we introduce our Indaba X steering committee. So if you're a member of the Indaba X steering committee, could you please hurriedly make your way to the front? If you're in the room and you're a member of the Indaba X steering committee, Dolo. Okay, I think I saw Daphne somewhere. Tatenda. Yes. All right, so this is the team that is doing wonderful things in the Indaba X community. Just as you can see, we are a big team with regional leads. So in case you need to be part of, I'll say, come and represent Volvian. Is Dauda here? Dauda? All right. Yeah, so that's the team. So we have a team lead, we have the tech lead, Daphne. So we have Leseho, who is the research and innovations lead. We have Stefan, who is the community lead for the Indaba X. We have Rim, who is our capacity building lead. I think she's not in. We have Anthony Dolo, who is the growth support lead for Eastern Africa. Yeah. Refilo, is she in? Our sponsorship lead. We have Dauda, who is our lead for the Western region. I have Volvian, represented by Fautse, who is our lead for the Central, and she's also the community lead alongside Stefan. We have Yassine, who is for the Southern Africa. And then Aya, Northern Africa, and Amelia, who is our communications lead. So that's how big the team is. And this year we have presence in in 47 countries in the African continent. So that's where we are represented currently. Hope next year we shall hit the entire continent. Yeah.
Okay, so now it's time to showcase our talent from the different countries. So it's time for the Indaba X Spotlight Talks. We have a number of the nominees, or actually poster winners from the different countries, who will be showcasing what each country has to offer in terms of machine learning. So each one will get 5 minutes to do a presentation. So I'm going to hand over to them. 3 minutes, okay. So they really have to be very fast and to the point. Okay, so I'm going to start with the first one, if you will come up to the stage. And there won't be any formal introductions, you know what to do.
Hello, my name is Fahad Mohammed from Somalia. I want to present, my research on orthographic variability amongst Somali people in writing Somali script. And Somali language, despite being mother tongue of, millions of people, it has, faced challenges in writing, both writing and spoken, right? The observation is speaking challenge, writing challenge, and combining challenges. For example, here are 3 tables of writing, a sampled group of writing Somali script. As we can see in the first and the second part, there are some mistaken or misspelled words. And this is the correct one and standard one. So if a group of people assemble it for dictation, they do not write the words in standard form. And what was incredible is that if you dictate them another language like Arabic and English, they write, the correct form. Here is the data analysis that I made. For example, there is, how they can use Somali language, how they're written, how they, try to write Somali script in the standardization format. I have developed this platform to, help the Somali people to write their language in the standardization format, right? And it works using, machine learning and NLP technology. So that is my research. Thank you very much.
Thank you. Next.
My name is Amina Salifu, representing Indaba X Ghana. And I'm presenting on enhancing speech recognition through diverse shared features accent classification. So, I don't know how many of you in this room have actually tried using the Zoom transcription before. If you've tried it before, you realize that these automatic systems are not actually being robust. But if you haven't, I think you can have a trial of it after the conference. So in our work, we try to see if there are shared features among intra-native speakers, especially English language. And with this, we try to come up with mathematical models and then algorithms to extract these features. So if you want to learn more about this work, you meet me in poster number 3 for more details. Thank you.
Thank you. Next.
Good morning, everybody. I'm Arthur Kuhn, and I'm from Liberia. This the work we're doing. We are predicting pH level in groundwater in Greater Monrovia. So it's important because, as one of the philosophers said, a lot of us can live without love, but a lot of us cannot live without water. So water is quite important for us. So as part of this work, what we are trying to do, we are trying to explore the machine learning techniques. It's in terms of the performances of this model, specifically linear regression, decision tree, and of course the random forest. So it's important for the work that we do. And as a matter of fact, pH is a key indicator in water quality that we can determine for aquatic life and of course human health as well. So that's the importance. And why are we using machine learning? It's basically simple because the traditional model is time consuming and really costly. So we need to have another platform in order for us to do a much larger work. So if you're quite interested, well, you can meet us. That's how we structure the work in this format. But we can talk more when you meet us at the booth. So thank you very much.
Thank you, ladies and gentlemen. My name is Khotso Moholobela. I'm from Lesotho. Ladies and gentlemen, our farmers in Lesotho are facing a drastic decline in terms of yield production in crops such as sorghum, wheat, and many other essential crops. So this has forced most of our farmers to now having to depend in the neighboring countries such as South Africa. As you can imagine, this has caused this has caused more our farmers to heavily to buy these essential crops in our neighboring countries, and leading to high prices in terms of getting those crops. So, ladies and gentlemen, what we did was to come up with the solutions that we can do in order to mitigate these problems, because most of our farmers are facing the challenge of bird infestations in their crops, and which has declined their yield to the extent that they are not even able to sustain them as a family. So, ladies and gentlemen, what we did is we have collected a data set of different animal sounds, including the birds and many other animal sounds, and then trained our models. We are not just using one model in order to predict or classify this, but we are using different models, such as convolutional neural networks models and many other models, try to see how these models can complement each other in terms of predicting and making better classifications. So we have used an assembled method where we have combined and used the majority voting classes, where we can now be able to generalize and provide the better classification and prediction in terms of detecting the birds if they are there in our field. So, ladies and gentlemen, for now we are just using the sound sensors to detect if the birds are there, and we have integrated our model into the IoT equipment where we produce the hawk sounds in order to detect the birds in that area. And we are also using the ultrasonic loudspeaker transducers, where we are producing the high frequencies in order to detect the birds in that particular area. So we are also planning to use the image processing, where we will use the images of the birds and many other animals in order to be able to classify the animals that are in our fields and be able to detect them, so that we can help our farmers to now help improve their yield and have better food security. So thank you, ladies and gentlemen.
So hello everyone, my name is Nair Abdou Mohamed. I'm from Comoros Islands. And my research paper is called Transfer Learning from Swahili, Advancing Solution for Comorian Dialects. So about Comoros, Comoros Islands is a group of 4 islands in the Indian Ocean, and we spoke a variant of Swahili language, Swahili dialects. So the problem in the country is that we are less than 1 million of inhabitants, so we don't produce significant enough data set to be able to construct sufficient performant models. So the idea really was just to see to profit of the proximity between Comorian dialect and Swahili, and the fact that Swahili is a well-represented language as French, actually as English, honestly. So what you see here in the left, in the map, this is a classification of Bantu languages proposed by an ethnologue named Guthrie. As you see in the class G, we have, for example, we have Swahili, we have Comorian dialects, we have a lot of languages spoken in that region, and the idea was to see how we can construct for a first time data sets, and for a second time models using this representation of Swahili. So more concretely, my main contribution was 5 points, 4 to 5 points, is to construct a data set in Comoros Islands, and also construct, bridge the gap between the different dialects in the country, and also at the impact part is to see how we can demonstrate a significant NLP contribution that we can make with even low resource data set. And at the end of this experiment, we achieved a lot of data set and models that we could give to everyone who wants to contribute to this field in our country. And we experiment on 2 main use cases. The first use cases was in speech recognition. The second use cases was on machine translation. And actually, we have a lot of improvements to make because we use a synthetic data set, data obtained through transfer learning. So we have to, for a next step, to see how we can make time out. Ah, really? Yeah. Okay, no problem. Sorry. We Comorian, we speak a lot. Thank you, everyone.
Hello, I'm Dr. Barkawi Mansour, representing Indaba X Niger. So, did you know that every year, did you know that every year 40% of the global agriculture production is lost due to disease and pests? Also, these cost up to $220 billion that affected by crop and disease. So the challenge, our challenge here is to use geospatial data combined with artificial intelligence to detect Leucotomia crop pest. For this, our workflow is presented like this. So data collection and also train our machine learning models using random forest to recommend intervention strategies. So this, as a result, we can get the model perform, the random model perform better than SVM, gradient boosting, and also the curve, the rock curve is better than the random forest curve is better than SVM, that allow us distinguishing between healthy crop and also infested crop. So this result allows us to detect, I can say, disease pest detection due to Totomia pest in Gaia city, based in Niger. So for more information, so we can sit together as the poster. Thank you.
The next presentation is going to be in French, so please use the link that's available on Slack to Kudo to translate to English.
Bonjour, moi c'est M. Aladoum Doubayo et M. Abdelrahman Haran. Nous sommes de la communauté tchadienne de l'IA et de la data science. Notre présentation aujourd'hui souhaite insister davantage sur le système d'alerte précoce basé sur l'IA au Tchad. Et le Tchad, pays d'Afrique centrale, connaît depuis des décennies des conflits récurrents entre éleveurs et agriculteurs. Ces conflits sont souvent liés aux ressources, à la compétition, pardon, aux ressources naturelles telles que la terre et l'eau, ont des conséquences désastreuses sur la vie humaine et les communautés locales. Les principaux facteurs de conflit résident sur la compétition, l'environnemental, le socio-environnementaux et les ressources, comme je viens de le dire. Le rôle de l'IA dans le système, c'est que nous avons eu à récolter les données. Les données sont les données géospatiales, les données également environnementales, les données du projet ACLD que nous avons eu à utiliser afin de modéliser avec la technologie d'apprentissage machine learning, y compris le système de vecteur machine, le random forest et la régression logistique afin de modéliser nos systèmes en mettant sur place ce qu'on appelle les détecteurs, le capteur d'alerte en temps réel pour prévenir ces conflits à tout moment. Je laisse la parole à M. Abdel.
Très bien, bonjour. Moi, c'est Abdelaziz Saran. Donc, je vais vous présenter les différents modèles qu'on a utilisés pour la prédiction des conflits. Il faut savoir que c'est en 2021, selon le rapport de l'ONU, le conflit entre agriculteurs et éleveurs a causé les morts de 309 personnes. Donc, c'est énorme. Pour cela, notre objectif, c'est de pouvoir proposer un système qui permet de prévoir surtout ces conflits. Pour cela, on a utilisé les trois modèles que vous voyez ici, le Logistic Regression, et puis Random Forest et le SVM. Ces trois modèles nous ont montré un résultat et le travail, c'est en continuité, ce n'est pas terminé. Donc, on est en train d'améliorer et de pouvoir proposer un système à travers une application mobile qui permettra aux autorités de pouvoir prévoir le conflit entre agriculteurs et éleveurs et de déployer les autorités, de déployer les moyens afin d'éviter ce conflit. Donc, en conclusion, il faut savoir que le conflit entre agriculteurs et éleveurs est beaucoup plus présent en Afrique, c'est récurrent, et surtout dans notre pays. Donc, il nous a paru très essentiel d'utiliser l'intelligence artificielle et de pouvoir proposer un système qui peut résoudre ces conflits. Donc, même notre communauté, déjà, sur de l'intelligence artificielle et de la data science, prend déjà l'utilisation de l'IA pour proposer des solutions axées sur la data et l'intelligence artificielle. On vous remercie.
Okay, good morning everyone. My name is Balay Chatou from Indaba Ethiopia, and I'm lecturer and researcher at Hawass University, Ethiopia. So I'm going to present my research here. My research title is Modeling and Design of Amphis Dynamic Sliding Mode Controller for Neurosis of Hemiplegia. So for a person to work properly, the neuromuscular and musculoskeletal connection need to work properly. So any pathologies that cause the working impairment may become hemiplegia. That means the effect of working properly may be caused because of hemiplegia. Stroke is one of the reasons that cause working deviation. So as you can see here, because of stroke, a person cannot work well. So as you can see here, we will have some hyperextension and loss of strength. So a person who is affected by stroke cannot work properly. So as you can see from the graph, there is a significant deviation between normal person and the one which is affected by stroke. So the blue graph is the normal gait analysis from normal person, and the orange one is the one affected with a stroke. So our research focus on resolving this gap by using machine learning algorithm, which is called AMPHIS, Adaptive Neuropathy Inference System. So by using this algorithm, we are able to mitigate the hyperextension and loss of strings in stroke patients. So we will discuss more about this in the poster session. So my poster number is poster number 8. So we will see in detail there. But we can see here that the controller that we deployed is AMPHIS dynamic sliding mode. So it's perfectly mitigated and resolved the problem of hemiplegic person and which is affected by stroke. So it is really well doing, because machine learning can be applied also in the robotic application to correct the gait of person affected by stroke. So we will discuss more in the poster session. So thank you so much. Amasagnalo.
The next presentation will also be in French. If you want translation, please use the kudos link.
In English. Okay, good morning everyone. I'm Verlon from Republic of Congo. So my presentation today is be about a comparative study of Bitcoin and Ripple cryptocurrencies using deep reinforcement learning methods. So, high volatility and dynamic nature of cryptocurrency market making it challenges and attractive. And the objective of this work is to compare different methods, different deep reinforcement learning methods like DeepQ network, double DeepQ network, dueling DeepQ network, and advantage actor critique A to C. So as a methodology also, we consider the Markov decision process, like a model trading as a series of decision steps in discrete time. And we consider also the state space, including the historical price, return, and technical, like MACD and RSSI. For the action space, include buy, sell, and hold. And for a reward function designed to maximize the portfolio return, penalizing the ACT transaction, both series and risky trades. So for the algorithm, as I said before, we have GQN, dueling, double, and advantage guarding. So for the data set, we consider our data set for XRP or Ripple and Bitcoin from 2015 to 2023. So we take data in Yahoo Finance. And as an evaluation metric, we consider the portfolio wealth and the trading signal were used to access the effectiveness of the GIF-RL strategies. The XRP performance. For the XRP performance, the double GQN and the dueling GQN perform extremely well for the Ripple, and the double GQN perform well for the Bitcoin. For more detail, you can see the poster. Jeff.
Okay, for real this time. This one is in French. If you have joined previously with the link, please just join again, refresh, and choose English. English.
Bonjour, je me nomme Afola Kosi. Bonjour, je me nomme Afola Kossi, représentant de Indaba East Togo. Vous savez, tous les 40 secondes, quelqu'un dans le monde souffre de maladies cardiovasculaires. Donc, notre objectif, c'est de réduire la prévention du risque cardiovasculaire dans le pays. Donc, on va utiliser une méthode une méthode pour pouvoir adapter notre méthodologie pour la réduction du risque cardiovasculaire. Alors, notre modèle, on avait commencé par le temps d'admission avec le temps de... On a utilisé aussi le temps après 24 heures, le temps après 3 jours. L'objectif, c'est de faire quoi? C'est de pouvoir classifier les individus par quoi? Par une méthode et par le principe de principal component element et puis le K-mean clustering. Maintenant, qu'est-ce qu'on a constaté? On a constaté que en utilisant le modèle de gradient boosting et random forest, on a réalisé que gradient boosting a une réduction de faux négatifs qui est égale à 15. C'est notre objectif. Ici, on a utilisé le modèle de cost proportional hazard and Kipmaya. À ma gauche, c'est le cost proportional avec une précision de 0,993. De l'autre côté, à ma droite, on a aussi utilisé le survival analysis. OK. Ici, le travail n'est pas encore fini. Notre objectif, c'est de faire quoi? C'est de pouvoir réduire le risque de cardiovasculaire pour une intervention plus rapide dans le pays. Et bon, on a constaté qu'ici, il n'y a pas les données pour pouvoir élargir notre donnée dans le monde et puis utiliser ces prototypes pour pouvoir aider les éléments, bon, la population dans notre pays. Merci.
Diane? Okay. You need to come. You can sit. I think for people in ML, mathematics is not our strong suit.
Good morning, everyone. I'm so happy to be here presenting my project in front of you. I'm representing Indaba X Rwanda, and I'm from Carnegie Mellon University, Africa. I'll be presenting the planning Indaba-based region, segmentation for early detection in Rwanda. I believe everyone got the push to why you start your project, and mine is about my mom. I lost my mom last year in August, and it was because of liver tumor. And from then, I was like, no, there's nobody's gonna die from liver tumor for as long as I'm still alive. So that was the push, the main purpose to why I started the project. And the bit of basic of another push to why I started, in Rwanda, we're still behind when it comes to liver tumor or when it comes to cancer in general. In 2020, 706 cases were reported, and 12% of the death cases were from Rwanda. This year, 41,365 cases were reported, and again, 13% of the cases were reported from Rwanda. So that's a big number for people to keep dying, yet we, the scientists, are still there. How are we doing that? The methodology are we using? We are using LesNet and UNet for segmentation and LesNet for prediction. In the preparatory processing, that's where we mask the images and be able to increase the capacity of the images, like we see the region to how the livers are being affected by the tumor. And in the post-processing, that's where we will be able to detect the accuracy of how our models is working well. I'm moving forward to result and discussion. These two images, we used the intersection of a union and the training losses over the accuracy. So these two images shows the increase in the training and the accuracy of the model, which means our model is actually doing so well. We were able to have 0.93, that's 93% of the accuracy. Thank you very much. For the next session, kindly let's meet outside for the poster session and be able to provide more information. Thank you very much.
Good morning, everyone. My name is Munenyasha, and today I'm excited to share with you how we can use cutting-edge technology to solve some of the most pressing challenges in the world, particularly in the field of dynamic particle motion. Right. So imagine that you're trying to understand how a life-saving drug spreads through the bloodstream, or how we can better predict the spread of pollutants in the water or in the air. These are all about dynamic particle motion. Traditionally, we've used methods that work fine with simpler situations, but when we need to deal with complex real-life scenarios, they tend to slow us down and to slow medical research, and leaving us unprepared for environmental disasters. And henceforth, machine learning offers us a new way forward with models that can handle these complexities better, faster, and more accurately. Right. So, methodology. This was a comparative study between how algorithmic approaches versus machine learning approaches would fare in terms of solving dynamic particle motion. So when it comes to traditional methods, we've used methods like the Euler's and the Veillette integration, which are good for basic scenarios, but they struggle with more complex and real-world problems. For example, the Runge-Kutta is very precise, but becomes increasingly difficult to manage when the situation gets more complex. Now, with machine learning approaches, we can use models that learn from data, making them better suited for handling complex and unpredictable environments. In this instance, we used the recurrent neural networks that can track how things change over time. And with convolutional neural networks, we can focus on spatial features like how pollutants might spread across a city. And we also have experimented with transformers and GNNs, which can model more complex relationships, like how different particles interact within our bodies and in the atmosphere. All right.
You have 1 minute to go.
Okay. Thank you. I think I'm done.
Thank you. Good morning. I'm David Geshohi from Kenya. I'm presenting a project on using ensemble learning for fraud detection in motor insurance claims. And the question that we're asking ourselves here is, when you take insurance, like in Kenya, for the year 2021, they collected a premium of 2 billion USD. Out of this, they paid claims of 1.4 billion USD. And research shows that approximately 10% of all claims are fraudulent. That means the country Kenya loses 100 million USD every year to fraud. Now, some approaches have been used by insurance companies to detect fraud, such as code of conduct, impromptu audit, but they are becoming infeasible due to the evolution of these fraudsters. So we came up with a solution whereby we are collecting data, and this data we collect and prepare it. We develop a predictive modeling and improve on this prediction by use of an ensemble technique. We chose on XGBoost as the ensemble algorithm that we are going to use, and also combined it with oversampling technique known as SMOT. And from this, we did experiments before oversampling and after oversampling. And what we could see is for class 0, that is the valid claims, before and after oversampling, the model is performing quite well, both precision, recall, and F1 score. But for the positive class, where we have fraudulent claims, before oversampling, the performance is quite bad, including a recall of 1%. So after doing oversampling, also before oversampling, we could know that the area of the curve is only at the threshold, the 50%. But when using this XGBoost, combining with SMOT, the performance is improving well from 25% precision to 100%, recall also improving, F1 score improving, and as well as the area at the curve improving from 50% to 83%. So what we are saying here is we are leveraging on the knowledge that is available in the huge data in the insurance companies, whereby we are providing them with a solution where they could be able to detect fraud claim present to them. And once they are able to do that, they'll satisfy the customers. And once the customers are satisfied, they'll not be lodging fraudulent claims to them. Thereby, the companies will be making profits. When they make profits, they reduce the premium rating and they make the insurance affordable to everyone. And therefore, that means that if you're able to collaborate with insurance companies, then we're able to solve this problem. Thank you. Let's meet at poster number 12. Thank you.
Is Ngele Emmanuel here? Yes, come.
Okay, the color. Yeah. So my name is Anthony, and I'm presenting the paper. It's called Geosemantic Profiling of brand-specific customer experience using social media comments. Okay, yeah, so this work was done by one of my interns. I provided full supervision, but he wasn't able to attend here. Can you go to the next? Okay, so I can't even see anything here. Okay, so the context here is that we're trying to, build a system where brands can actually know their customers' experience across different geographical locations. So the first is that it's very important for brands to know how their customers feel about them, across so many geographical locations. So we saw that traditional sentiment analysis don't even have that kind of geographic context. So we're trying to combine geospatial analysis with NLP to build some insights. Okay, so the methodology here is we did data collection. We collected data from Twitter, and also we focused on Access Bank as a use case, and then we try to annotate the data to get the locations, and then we train an NER model using SPACE, and then we try to use sentiment analysis. Although here we didn't train the model, we use already existing model to get the sentiment across the comments. And then we try to get the coordinates of those places where customers are complaining about the brand. The problems they're having and how they're expressing their experience across the brand, right? And then we try to build a network diagram that shows the relationship of what they are saying, in a network diagram, yeah. So this is just like the results. We have the map, which shows the coordinates where the people are complaining, because this data was collected in Lagos, and the model was trained and it's got 81% accuracy, and then this is the results. Try to visualize the comments, how they relate to each other. So key takeaway is that this approach can help businesses to gain deeper understanding of customer experience across different regions, which can lead to more effective localized marketing strategy. And the impact is that we are able to combine NER, sentiment analysis, and geospatial, to really get understanding of how brands can actually improve on different regions, delivering their services. So the future work is that we've done this on a particular brand like Access Bank, like I mentioned. We're looking forward to do this across other stuff that has to do with getting the insight about the geography and everything. Yeah, thank you.
Is John here? Emily. Albano dos Santos, are you here? Emily.
Good morning, everyone. My name is Emily Rose Steen, and I'm a master's student from the University of the Witwatersrand in Johannesburg, South Africa. And I'm really excited to be here to present a little bit about my research, which is measuring quality of life from satellite images. And specifically what I'm doing is taking local survey data that has this quality of life index And I'm trying to predict that from satellite images. Apologies for the color. It was originally a white background, but pretty much I'm training a machine learning model to predict this quality of life index from satellite image tiles. Now, previous research in this space focused on predicting poverty, so that was an asset wealth index, and I'm trying to predict a quality of life index which encompasses a more multidimensional view of socioeconomic development. So it includes aspects like access to electricity, water, education, healthcare, as well as socioeconomic well-being. Now, the preliminary findings are that approaches for predicting poverty from satellite images do not transfer so well to the specific quality of life index. And that could be for a number of reasons. So, for example, this quality of life index includes parameters for life satisfaction, which we would expect probably is not very well predictable from satellite images. So currently what I'm working on is validating my implementation. I'm investigating whether or not more training data or multimodal data would help me. And in the long run, I'd really like to actually predict sub-indicators of this quality of life survey or other surveys to really test the boundaries of what we can measure from satellite images when it comes to socioeconomic development. Now, before I conclude, I just want to touch on why this research is important. In many developing countries in Africa and around the world, we face a real challenge with collecting good quality, frequent data about socioeconomic development. The censuses or nationally representative surveys are really expensive to run and quite logistically complicated. And so we often only collect this data once every 10 years or so. And these kinds of tools, this kind of research, would really help us just collect more data more regularly from big data like satellite images about what people's lives are like on the ground, which would help us in terms of driving and tracking policies which actually improve people's lives. So thanks so much for listening to me this morning. I will be presenting a poster today in the Indaba X session at 10:30. I think my poster number is 14. But yeah, if you have any questions or feedback or suggestions, please do come find me. Thanks so much.
Okay, the next presentation is going to be in French. Please use the kudos link if you want English translation.
Oui. Bonjour à tout le monde, je me nomme Willy Ahmed Joseph et je vais vous présenter un peu nos travaux sur la traduction automatique des langues du Burkina, et dont on a commencé d'abord par le moré. Alors, les langues sont en fait une richesse pour l'Afrique. On a une bonne diversité des langues, surtout aussi au Burkina où on a environ une soixantaine de langues. Le moré représente ici, parmi ces soixantaine de langues, environ plus de 50% de la population parle le moré. Alors, ce qui crée un certain nombre de problèmes comme la communication interlinguistique, le partage des informations, l'accès à l'information dans certaines zones urbaines. Donc, on nous sommes proposés dans ce cas de proposer une solution basée sur l'IA qui, dans le cas général, englobe toute l'Afrique. Même pour le cas initial, on va commencer au niveau local et principalement sur le moré. Alors, comme le moré est une langue à faible ressource, c'est-à-dire qu'on n'a pas suffisamment de données pour pouvoir l'entraîner, nous sommes rabattus un peu sur des données que nous avons pu trouver en ligne, qui sont pour la plupart des données bibliques, que nous avons pu scraper sur les données sur le site web des témoins de Jéhovah. Aussi, nous avons trouvé quelques données des déclarations de droits humains qu'ils ont fait l'effort de traduire ça en moré, ainsi que le dictionnaire moré. Mais parmi ces données que nous avons trouvées, sur 32 000 lignes, on avait 30 lignes qui représentaient les données bibliques. Donc du coup, le modèle que nous avons obtenu est un modèle qui est beaucoup plus axé sur les données bibliques que de façon générale. Alors, l'architecture que nous avons adoptée pour pouvoir mener à bien ce travail, c'est d'abord collecter les données, comme on en manquait, après les aligner pour qu'on puisse les utiliser, et ensuite proposer un tokeniseur pour que la machine quand même puisse comprendre les différents mots et langues des phrases que nous avons en moré. Étant donné qu'on voulait le traduire vers le français, donc aussi on avait un tokeniseur en français, et la suite du travail, c'est de pouvoir faire la traduction en moré, en dioula et dans d'autres langues aussi. Ok. Donc nous avons utilisé ici, après recherche dans la littérature, l'architecture transformer pour pouvoir mettre en place notre modèle, et à la fin on a un modèle de langue que nous avons pu déployer. Alors, pour les résultats, ici nous pouvons constater dans le tableau qui est là que les données sur et les témoins de Jéhovah ont des bons scores, mais lorsqu'on ajoute les autres données, on a un score qui diminue en fait. C'est juste que les données des témoins de Jéhovah, c'est assez grand et assez homogène, donc suffisamment, le modèle apprend facilement là-bas. Mais lorsqu'on ajoute des données plus petites avec d'autres domaines linguistiques, ça entraîne du bruit, donc ce qui explique un peu cette chute plutôt. Donc nous avons les limitations liées aux ressources, et donc la suite du travail, c'est de pouvoir voir d'autres techniques comme le transfer learning, le fine-tuning, et aussi collecter d'autres données pour pouvoir améliorer notre modèle. Alors, merci beaucoup.
Okay, good morning, everyone. My name is Laiton Kalumba, a student at the Copperbelt University in Zambia. With me here is my presentation on my research, improving maternal health care in Zambia using AI. Maternal health care in Zambia faces significant challenges. With a mortality rate of 213 per 100,000 live births and a neonatal mortality rate of 27 per 1,000 live births. The aim of this research was to enhance maternal health outcomes by developing predictive models that identify high-risk pregnancies early using AI. So the graphs below contain the maternal mortality rate in Africa and Zambia at large. So we can see that the graph of Africa is, the continent of Africa has the highest mortality rates, and then this one here is Zambia, which still remain relatively high compared to other continents. Methodology and results of this research, we collected 100% Zambian data from rural areas which contained 1,001 data points. And then for the model, we built machine learning models, and then we further refined them using BERT. Our models showcased strong performance. As you can see, summarized performances of 85% accuracy, 82% precision, 80% recall, and 81% F1 score. And the graphs there contain the comparisons of the models. Some models even got to up to 95% and more. For our conclusion, integrating models like BERT enhances the prediction of high-risk pregnancies, supporting timely interventions, and potentially reducing maternal health care risks. Our recommendations, we recommend deploying models in healthcare settings for early detection, expand the collection of efforts to refine these models and make them better. We'd like to acknowledge our partnership with Dawa Health, which is a maternal health startup in Zambia, which helped us to do this research. So with that being said, this is the end of my presentation. I'll be at Poster 24 if you want to win a free high five.
So you have to keep refreshing.
Good morning, everyone. My name is Jonathan Muchibi, and I'll be talking about our research at the Makerere Artificial Intelligence Lab at Makerere University, but also representing Indaba X Uganda. The topic is machine learning analysis of radio data to uncover community perceptions on the Ebola outbreak in Uganda. So ideally, we try to look at a case whereby where we have a digital divide and the internet penetration is low, which means people can't post their perceptions on platforms like Twitter or Facebook. So in such a scenario, how can we get to understand the perceptions of the communities in terms of the government interventions and some of the things that could be actually disturbing them so that the right interventions can be done. For example, if you look at Uganda, where the Ebola outbreak was, in the western Uganda, you find that these are communities which we can define as offline communities, where interventions were made because there was an Ebola outbreak. So how can we try to understand the perceptions of people in terms of vaccines and quite a lot of other government interventions, and yet they are offline communities. So what we do, we develop a radio pipeline where we try to use radio data because if we look at the radio usage compared to other platforms like Twitter and Facebook or social media platforms, most people in the global south and sub-Saharan Africa actually own a radio where they can actually call in and exchange their views on radio and quite on a lot of different topics. So what we do is we come up with a pipeline which involves data engineering approaches and deploying models in local languages and also Ugandan English, and try to evaluate what exactly people are talking about on radio. And with this, we are able to get some of the highlights of what people are talking about in terms of the different symptoms which they're experiencing across different gender, and also try to understand basically which gender is being affected by what. And with this, in collaboration with the government and Ministry of Health, the right interventions can be made and the right sensitization can be done. So I look forward to seeing you on poster number 19 to exchange more details about the technical ideas and research questions we try to address around this problem. Thank you.
Hello everyone, my name is Walid. I am from Morocco, a PhD student doing quantum machine learning. So today I'm presenting you quantum machine learning for oncological diagnosis. So in our work, we are integrating quantum machine learning technology in cancer diagnosis. And we are focusing on two new advanced technologies which is called quantum convolution and neural network. We deploy them for brain tumors and also use quantum support vector machine, which is the quantum version of the support vector machine method. And we deploy it for enhancing prostate cancer detection. And our aim here is to develop hybrid quantum classical algorithm which leverage both quantum and classical strengths. And for this, we are trying to make, to enhance current existing machine learning diagnosis tool to make them faster and more precise for cancer detection. So as you can see in our first model, we have brain tumors encoded into our model, quantum model. So we use quantum convolution and quantum pooling in order to extract features, informative features and complex features from our data. And then we feed it into a classical layer, which is a fully connected layer in order to do classification. And in the next model, which is a quantum support vector machine, So we use quantum circuits in order to map the data set into a higher dimension, which is called the Hilbert space. And then we compute the similarity between data into quantum circuits. And we run it on a quantum computer. And this is an example of a quantum computer, which is called a superconducting quantum computer. And yeah, so after computer the kernel, we use also classical technique in order to do optimization and classify our data set.
You have 1 minute to stop. 1 minute.
Okay, thank you. So for our model, quantum convolution and neural network, we achieve 99.67% accuracy, which is very interesting. That shows us that this quantum convolution and neural network can handle complex medical imaging and data with higher precision. And this is apparent from the confusion matrix, which shows excellent performance across the different tumor types. And for quantum support vector machine, we have an improved result compared to the classical one. And this is apparent from the kernel matrix, which shows a clear separation of data set compared to the classical method. Yeah, so apart of that, I'm working on quantum machine learning security, where I'm trying to investigate how quantum machine learning can improve anomaly detection and how it can be targeted with cyber attacks. So I'm trying to improve quantum models for this sake. And thank you very much.
Good morning, everybody. My name is Dinerago Nashandi. I'm from Namibia, and I represent Namibia Indaba X. This work is part of my PhD works, and the title is Development of an AI-driven domain-based complex problem-solving approach. We are arguing that any problem that requires more than one action to be solved is defined as complex problems, right? However, if you are confronted with a complex problem that is relying very much on the domain, the best approach to solve those problems is to have domain knowledge or to rely on domain knowledge with the help of domain experts. However, the current techniques such as LLMs, they are too genetics, or they are not domain specific. Hence, we are trying to create an approach that is actually relying on AI techniques by creating the approach to solve those domain-based problems. The approach is going to rely on domain knowledge base with the help of domain experts. The work is still on early stage. It's on the proposal stage, and we have defined the main objectives and the questions. The main objective will be then to try to combine existing solutions in a domain to solve those complex problems. And then the sub-objective will then to define the domain interest. And then we are arguing that if we are constraining those approaches or the approach to solve the problems to the domain, it will only make sense for you to also to constrain the data set that are going to be used to the domain. Hence, what we are going to do is also to create a data integration approach that will then address the inconsistency in data from different data sources. And then the second last objective will then develop the best strategy for the implementation of the abstract actions, because what are we talking about? The abstract actions is to define or to help to understand the complex problems. We will then implement or follow the AI techniques or the AI planning technique to help with the decompositions and the breaking of the complex problems, so that it can help the problem solver to better understand or conceptualize the problems. And then the last part will then test the effectiveness of the approach. This is the approach. Sorry, it might not be visible, I think, but then it will be visible in the poster. The architecture of the approach consists of three modules. The first module is the AI planning techniques, where you define or you break the problem or define the problem definition and the domain definition following the AI planning techniques. And then once you have done that, you then generate a plan, the AI plan.
Thank you. Time out.
Thank you.
Thank you so much. I'm Justin Moskolai from University of Douala, representing Indaba X Cameroon. So I would like here to talk about the contribution of urban intelligence for sustainable transportation in Africa. The main context or the motivation of our research based on the rapid growth of population in the main cities of Africa, like Lagos, like Douala, like Dakar, like Abidjan, like Pretoria, for example. So that situations need to find the solution in order to resolve the problem of traffic in these cities. And then we have also another opportunities, like the high penetration of mobile phone in Africa, and also so many information that we generate. So we would like in this study to show just the opportunities and challenges to use the data come from city in order to take the best decisions for solutions, for sustainable solutions in Africa. That's why we will use here the urban intelligence. What is the urban intelligence? Urban intelligence is just here the application of artificial intelligence in order to solve the problem relative to the cities, like energy, like transportation system, like health system. So we will collect the data through, for example, some sensors, some camera, something like that, in order to take the best decision. In our research, we will focus on the transportation system, and that we propose here the methodological framework based on the integrated approach on the engineering system and machine learning techniques in order to help decision makers to take the best decision relative on transportation system. So to validate this model, we have deploy and apply the case study based on the city of Yaoundé, okay? So we have collected around 3 million recorded GPS positions and for 42 taxis during 1 month, and then we have generated this figure here. You can have exactly the different positions and localization of the traffic jams. And also we have the different information indicator about the time of the peak of traffic jams. This solution can help a decision maker to predict, for example, human mobility path and traffic congestion, and then help them to provide the best solutions. So in future direction, we would like to implement it with digital twins solutions. Thank you so much. I'm poster number 28.
Hello everyone. I'm Iman Hamzawi and I'm here to represent Indaba X Algeria, and the slides were supposed to be white. The brain has long been a place of inspiration for designing neural network architectures, and they are similar in many ways. In terms of architecture, the number of layers, we have weights, and the way learning happens. So this has led us to think about bio-inspired neural networks and their intrinsic adversarial robustness, but usually they don't yield in high accuracy. And neural architecture search permits to find optimal architectures. So we thought about combining neural architecture search, but not only to search for the architecture, but also for the learning rule. This is how we propose BioNAS, with mixing learning rules as well as architectures. So the way it's done is by using a super network, which is a very common neural architecture search method, and combining into these blocks the learning rules. So instead of doing the classical backpropagation in the backward pass, we use different feedback matrices. So we use a baseline of darts and EGNAS. EGNAS is more lightweight, and we were able to achieve state-of-the-art bio-inspired neural network accuracy on CFAR10, CFAR100, and even on ImageNet 1620, which is part of NASBench. And for more details, you can find me at poster number 36, and sorry for the blurry slides. Thank you.
Good morning. So I'm Christina Jiziwa, a biomedical engineer working with Impala project. So you can go online to find more about the custodian. And the aim of this Impala project is to create an ecosystem of error detection in clinical settings. So I'm going to present on one of the papers that I'm working on, which is pattern learning algorithm on threshold alarms around critical illness events in patient monitoring. And these critical illness events, we're talking about respiratory support, sepsis, death, and others. So I'm only working on sepsis and death. And so the Impala system is more like a system that is consisting of the patient monitoring, the biosystem, which is more about sample correction, the cost management of the medical equipment. So this Impala system is just a representation of patient monitor. As you can see, there's a patient monitor, and there's an app, and there's a server which stores the information and the connection to the patient. So this is just a presentation of the patient monitoring system itself. So from my research, as I said, as I'm working on a patient pattern learning algorithm, so this is just a representation of the threshold alarms. So these are being generated from the vital sign of a patient, and namely we can talk about the SpO2, ECG heart rate, ECG, HR, the NAB heart blood pressure, temperature, and many others. So I'm only working on 3 of them. So this is just a presentation of the vital sign prior to the occurrence of the CIE, which in our instance is death. And using the DB scan clustering, we were able to cluster these elements in terms of the duration and also the density occurrence of these threshold alarms, from which we're going now to use our machine learning algorithm to predict the occurrence of this CIE. So this is just a clustering presentation of the DB scan that we used on our vital sign of the threshold alarms. So using the support length vector machine.
Thank you. Next.
You find me person. 30.
Good morning. My name is Blessing Spanda, representing Indaba X Zimbabwe and Data Science Zimbabwe, and present on the process for creation of a translation dataset for Zimbabwean languages, which is still work in progress. So Zimbabwe has 16 official languages, and there's been a lot of push to create resources for low resource languages. In Zimbabwe, those have been mostly been focused on Shona, which is the most dominant language in Zimbabwe. But other languages have been left out. So with this project, we make use of the NDS1 documents, which are National Development Strategic 1 documents created by the government for the Vision 2030, but this is the first part, which is from 2020 to 2025, and has been translated into 14 official languages as a starting point to create the data sets. So in terms of the objectives, we, inspired by Masakane, we are doing a participatory research where we develop a standardized methodology and pipelines for extracting, processing, matching, and aligning textual data from the NDS1 documents. So this is, and then we then create a parallel corpora for the 13 languages in the NDS1, and then train benchmarks for models for the created data set. So for the initial curation, we have done about 2,534 parallel sentences for Shona. So we have started with Shona to get to understand the problems with the documents that we are using, and then to use that as a base for creating the pipelines. And then from then, we are moving on to the community to use those pipelines for other languages in the NDS1 documents.
Thank you.
For more, visit poster number 9. Thank you very much.
Good morning, everyone. My name is Ariane Wataosu. I come from University of Abomey-Calavi in Benin. I represent Indaba, Benin Republic. My research is entitled Empirical Performance of Deep Learning Model for Crop Classification, for crop disease classification. So this work is part of my PhD thesis, and it was being done with the contribution of Dr. Kasro Humenu, Hatel Hunji, and Professor Romain Glele-Kakai. So deep learning is a type of machine learning which uses many layers to analyze complex pattern data, but it's more efficient when in the different classes we have the data are balanced. But sometimes we face a class imbalance situation, especially for some scarce diseases in agriculture and healthcare. This work aims to evaluate the performance of the most used deep learning technique for crop disease classification. I mean Google Net, ResNet 50, and VGG 16. So for this purpose, we consider data flow from plant village and plant disease. We randomly choose 2,000 images for training, 127 for testing. We use from 10 to 90% of the diseases class. Random oversampling and random oversampling. Okay. The results show that random oversampling and random undersampling improve the performance of the model. Thank you for your attention. If you want to know more about my research, please come to my poster at number 6. Thank you.
Buenos días a todos. Mi nombre es Remias.
Good day, everyone. My name is Jeremiah, and I'm representing Indaba X, Equatorial Guinea. I speak Spanish, Portuguese, and French. I'm presenting a poster on a beautiful African European personality called Afia Carlos, which means good health, Swahili, and Greek. And just a quick background to this research. So a couple of years ago, when I was doing a PhD, I had to drop out in my third year because I was overwhelmed with life situations and all of that. And I had to be strong for our employees and stakeholders, investors, and all of that. But then I would play songs and upload quotes, to express myself on WhatsApp, but I couldn't speak to anyone. And of course, there was someone who could read the cryptic texts behind what I was posting. And, she would reach out and she would ask, are you really okay? Eventually, when I tried the second attempt at a PhD, I decided to build this beautiful personality called Afia Carlos. And the research really aims to understand the hidden text, hidden meanings behind what people post on social media. Now, some of the things you would actually see there, some posts there. A lion does not concern himself with the opinions of a sheep. You feel like stopping, but the world keeps rolling around. I guess some things are just left unsaid. And that's Afia Carlos, who is meant to be an online personality, a celebrity, who reaches out to you understanding what you really are trying to say and just reaches out to you and be that friend. If you want to really know more about this beautiful African European personality, meet me by stand number 28, and I would see. Thank you.
Okay, so thank you, and I have only 2 minutes actually, so I will be as concise as possible since I'm not Eminem. Yeah. Next slide. I will present myself first. I'm Yakuba Jara, the Indaba X Mali representative. What? Yeah, okay. Sorry. So I'm Yakuba Jara, the Indaba X Mali representative at DCF Deep Learning Indaba. And yeah, I will present us as the Indaba X Mali organizers. Mali AI for D Lab is an independent pedagogical laboratory and a member of the Pan-African Network of AI for Development Labs, with a focus on AI for education. So I think before getting into our research, it's important to pose the context in which those research are really relevant. Education is still a challenge in Mali. We have more than 2/3 of the population that are illiterate, and a complaint that people were often making these recent years is that they would like their kids to be taught in their mother tongue, actually, to be able to generate and create and innovate in their mother tongue instead of the French language. So, and this is what we at Mali took as our mission. So our research focused on creating resources and harnessing and developing AI technologies and applications for education in Mali. So on the poster that I will be presenting in a few minutes, I will present an application that we developed, built on top of some of our previous projects and OpenAI Whisper model that aim to teach kids how to read in their mother tongue, that incorporate some of our previous projects like the Generative AI for Education project, where we generated storybooks for kids. And yeah, I need to be really concise. So if you want to know more about it, just find me. I forgot the poster number, but it's just the bigger one. So they messed up with this. Thank you.
Yeah.
Good morning, everyone. My name is Ismail. So I'm here representing Indaba X Côte d'Ivoire. So I'm going to present a work on reducing the misdiagnosis of bacterial meningitis in West Africa. So to put a little context, is a very mortal or lethal disease which is caused by the bleeding or the bleeding of the tissue around the brain and also the spinal cord. So currently in the Medical Research Council in the Gambia, where I'm doing a postdoc, they are conducting a surveillance to look on the ground what is happening for this disease. So for like 10 years, they have been collecting data in these countries, and all the data is collected. So when a child goes to the hospital, for example, they do the different record and also the different tests on the site, like the hospital. Then they send a sample from the children to the main Medical Research Council lab. So they do some additional tests and they confirm or infirm the diagnosis that has been done on site. So looking at the data, what we found is that 70% of positive cases has been missed during all this time. And also we found that between the time that the child has been admitted at the hospital and the sample reaching the lab, it takes almost 4 months. So you can imagine if a child is sick and we don't know exactly that he's suffering for this disease, and after 4 months, the disease can progress and also can lead to even the death of a child. So here we pose a question here: how can we use machine learning to use the data that has been collected on the site, like the hospital, and to predict the result that will be found later after shipping the sample to the Gambia? So going first, here we have some preliminary results. We have been able to... Okay, thank you so much. So you can find me on the poster. I don't remember the number, but thank you.
Okay, hello everyone. My name is Charles Abdoulaye Ngom. I'm from Senegal, and I'm working at the ERD lab with some doctors from Aristide Le Dantec Hospital in Dakar. So I will present you my subject about atrial fibrillation risk prediction in pacemaker patients using artificial intelligence methods. So first of all, atrial fibrillation methods is cardiac arrhythmia. So that causing some disordered some disordered heart rate. So for the healthcare professionals to diagnose these atrial fibrillations, they use ECG. So ECG is aim to, no, yes, I'm coming. Aim to record some electrical activity of the heart. So we was able to retrieve 52 ECGs only, and 38 was lively, and 4 of them was from patients which have atrial fibrillation. So in the literature review, we use some data augmentation and conditional data generation, and we use some metrics like MMD, PRD, RMS. So in our process, the details are there, and the results shows us that the conditional generation was better than the data augmentation. So from here, we were able to use a model who already performed in cardiac arrhythmia prediction, such as atrial fibrillation. So we use transfer learning to predict from our own data set. So we generate limited ECG to avoid the distribution problem. So the experience shows us that our model didn't perform very well because of the lack of our data. So we use another data set from Brazil to perform our methodology, and we have some good results. So thank you very much. Our research results in two papers, one for the data generation. It is available in eTrasr, and another in who is in under review. So my poster is number 10. Thank you.
Okay, so that concludes. Oh, there's still people. Huh. So we have to refresh again. It seems we are going to sleep here. They don't want us to leave. Apologies, the internet is very slow.
Good morning, everyone. My name is Steiner Johnson, and I'm an AI student, and I come from Madagascar. And today, I'm excited to share with you my research project entitled Personalized Genomic Medicine in Lung Cancer, Leveraging Genomic Language Model for Precision Treatment. So, a little introduction. As we all know, lung cancer is the leading cause of cancer-related death globally. And today, with the high rate of smoking and pollution in Africa, it is important that we take this disease seriously. And with the high complexity of the genetic in lung cancer, it is difficult to give the best treatment for each patient. So to tackle this problem, this project focuses on the potential of genomic language model to improve mutation detection and treatment personalization. So the methodology of this research lies on different steps. First is the data collection with personally choose dataset from TCGA and NCBY. And after that is the model development. We've personally choose DNA birth and fine-tuned it to not only detect the mutation, but also find the mutation position and finds the type of the mutation. So for the treatment recommendation system and response prediction, we've used supervised learning algorithms to give the best treatment for each patient. And as for now, we are still in the part of developing and fine-tuning the genomic language model, and we anticipate to improve the precision of treatment recommendation. And finally, our next step is to use this application for other cancer type. Thank you.
Right, thank you for coming for this wonderful session. Just some brief announcements. The poster sessions are happening on this side of the building, so feel free to go check them out, give constructive feedback to the poster presenters. Yeah, I think that concludes the session, this session in this room. Yeah, see you. And we have another poster session after lunch for publications. So we shall remove these posters and put other posters after lunch. So you can also pass by and look at them.
Yes. Yes. Yeah. Une, deux, trois. C'est bon. Une, deux, trois. A, B, C.
naa la guddi gi yëpp ndax fajar yow laay jàkkaarloo bëggeelam xel xalaat la xol yëg la li tëg jëmam jë dara xaju fa xel xalaat la xalaatam ba xol yëg li tëg jëmam jë dara xaju dara xajul nit nag ak jëmmam ja dara fa xajul
समय का पहिया गोल है
gëstu woo ma dellu woo ma laaj lu xew gisuloo ma te gisoon naa ni danga réer ba lay jéem a foon tey loo ko ndax mbëggeel dafa naan di nga changé wala ma dem àndandoo bi si jamono ji am na xaar ba beneen xaritoo ma woo ma yee ma su fekkee may nelaw fu ñu toll dañuy góolu ku dul sa xel wala ma dem naa la wax ni am naa cofeel cofeel bi ma am si yow war naa ni doo ko yee walaay dem ma miin ba doo ma yéeg ba maa ngay dem gëstu woo ma gàddaay gàddaay yëguloo ma yow yëguloo ma falewuloo ma gàddaay gàddaay toppatoo ma yow toppatoo woo ma gëstu woo ma yëguloo ma yow yëguloo ma falewuloo ma
I know something wrong. Doomu yaay mbaa fàttewuloo mi. Woote naati wuyuwuloo mi. 'Cause I know something wrong. I know something wrong. Maa ngi dox tànk neen ci naaj bu tàng lool. Maa ngi mar naanu ndox jafe lool. I know. 'Cause I know something wrong. Gile jël si ma xarit sama doomu yaay fi ma tollu weena. Bile doomu yaay jël si ma xarit sama fi ma tollu weena.
doomu yaay jël sama xarit sama doomu yaay jël sama doomu yaay jël sama xarit sama doomu yaay jël sama gëstu woo ma lijjanti woo ma yow lijjanti woo ma falewuloo ma toppatoo ma yow toppatoo ma gëstu woo ma xooluloo ma yow yëguloo ma falewuloo ma lijjanti woo ma yow ba tax gàddaay naa gàddaay gàddaay nga changé balaa maa dem àndandoo bi si jamono ji mën na xaar ba beneen xarit woo ma yema su fekkee may nelaw fu ñu toll kañ ngay wóolu ku dul sa xel balaa maa dem naa la wax ni am naa cofeel cofeel bi ma am si yow waa naa ni doo ko yee walaay dem ma miin ba doo ma yéeg ba maa ngay dem gëstu woo ma gàddaay yëguloo ma yow yëguloo ma falewuloo ma toppatoo ma yow toppatoo woo ma gëstu woo ma yëguloo ma yow yëguloo ma falewuloo ma
I know something wrong. Doomu yaay mbaa fàttewuloo woote naati wuyuwuloo. 'Cause I know something wrong. I know something wrong. maa ngi dox ak tànk neen ci naaj bu tàng lool. maa ngi mar naan ndox yu jafe lool. I know. 'Cause I know something wrong. Gile jël si ma xarit sama doomu yaay fi ma tollu wee na. Bile doomu yaay jël si ma xarit sama fi ma tollu wee na.
doomu yaay jël sama xarit sama doomu yaay jël sama doomu yaay jël sama xarit sama doomu yaay jël sama gëstu woo ma lijjanti woo ma yow lijjanti woo ma falewuloo ma toppatoo ma yow toppatoo woo ma gëstu woo ma xooluloo ma yow yëguloo ma falewuloo ma lijjanti woo ma yow ba tax gàddaay naa
Gàddaayu gàddaay fii ku fi wàcc saw ànd àndoo dem fekk fa sa morom toog.
gëstu woo ma dellu woo ma may laaj lu xew gisuloo ma te gisoon naa ni danga réer bala jéerama foon tey loo ko ndax mbëggeel defar naa ni di nga changé balaa maa dem àndandoo bi si jamono ji mën na xaar ba beneen xarit woo ma yema su fekkee may nelaw fu ñu toll kañ ngay wóolu ku dul sa xel balaa maa dem naa la wax ni cofeel cofeel bi ma am si yow war naa ni doo ko yee walaay dem ma mi ba doo ma yéeg ba maa ngay dem gëstu woo ma gàddaay gàddaay yëguloo ma yow yëguloo ma falewuloo ma gàddaay gàddaay toppatoo ma yow toppatoo woo cosaanam bàyyi ko mu dem yàlla ndogalam toppal sa wee gor day nangu ndogal na toodi kerkeraan jam ku saagan sanko lapta doodu doo seet doo sela doo xam boromam
everyone. I hope you're having a great day so far. Just wanted to let you know there is a mentorship session now happening in Annex 1. There is lunch provided. If you have signed up for this, please go ahead. The mentor is there and waiting for you. Mentorship session in Annex 1.
learning, foundation models, novel architectures, safety plus alignment, and NLP. He have led and co-led several projects during his time. And now, without further ado, our guest today.
Thank you very much for the introduction. It's a really great pleasure to be here with all these amazing students and being in between all these excitements. And I've enjoyed so far this event so much, and I'm really looking forward to for the next couple of days. Today in my talk, I'll briefly talk about the limitations of current generation of LLMs and how to incorporate them into the society. So the goal of this talk, I could just pick one topic, or one slide from this presentation and make a 1 hour talk, but I decided rather than doing that, just give a brief overview of different limitations that we know that exist in these models, so that if there's anything particular that interests you, you can go further deep down into it. Because I noticed that many of you are coming from very diverse backgrounds, studying very different aspects of these models, and I decided to make it a bit more generic and maybe a bit high level as well, so that you can take the map and then explore the parts of these topics that I'll be discussing more deeply. And so there are a couple of points I'll touch in terms of limitations of these LLMs: hallucination, safety, and security. Reasoning part, Semi Benji already have introduced some limitations. I'll quickly go over it again just in case, to remind you of some of the concepts and the biases that Indaba also talk about as well. And then I'll briefly go into efficiency. I'll touch each one of these quite quickly, and then I'll present some interesting works that explore these topics a little bit further. So depending on who you ask, these frontier AI systems, they are the best things ever. Especially if you look online, if there are lots of tech bros that claim that those models are amazing, they are revolutionizing everything, and they are kind of the best thing people has ever invented since the invention of fire. But depending on who you ask, those models might cause catastrophic risks, or it can end the whole humanity, and it can have very bad consequences as well. But the question is which one is true? So I'll try to explore in my talk, try to get a bit more into this question. And my to give you a spoiler, my opinion is neither of these extreme opinions, in my opinion, are actually reflecting the the actuality, but it's somewhere more in between, basically. And we need to be aware of the limitations of these models so that we can actually deploy them more responsibly into the real world. So this is some generated MNIST digits that I generated in 2016 by training some form of variation autoencoder. And now, if you ask DALL-E 3 just to generate MNIST digits in the style of Da Vinci in The Last Supper, you can get this, basically. In 8 years, you can see the amount of progress that has happened, basically. And this text generated by a recurrent neural network language model that was trained by Andrei Karpathy, and he called it as Polgram generator. The reason he called it as Polgram generator is because he collected lots of data by blog posts written by Polgram. And then if you look at the text generated by this language model, it's completely crap. Nothing really makes sense. But a couple of days ago, it literally took me 2 seconds to write this, the prompt, and it actually generated Claude Sonnet 3.3, 3.5, generated something very sensible that could actually come from one of the blog posts of Polgram. So what has changed? The biggest thing that has changed from 2015 till now is basically the data and the scale. And if you look at the large language models, like especially the frontier AI models like ChatGPT, Cloud 3.5, and Gemini, we actually don't know much about them besides architecture, but like we have very little access to what type of data they are trained or what type of like models they are, architecture they use and all these things. And I realized that that also makes some people think that these are actually some mythical beasts. No one really understands what's going on. They are like Pokemons, like kind of like they are magical. Some things that just like emerges and no one really have any ideas about that. But that's like very far from truth. Those are the models that we train and they are basically a bunch of mathematical equations. And actually if we spend time and try to understand, we can get lots of insights about them. And they are very far from being mythical or things that we cannot interpret or understand at all. Now I will quickly give you a very, very brief background just to remind you what language modeling is in case some of you are not familiar with. So one of the main secret ingredients behind these like frontier AI models is the autoregressive sequence models. The way these models are trained is basically you give a sequence of tokens, and given that sequence of tokens, they create a summary of the context, and they try to predict the next token in the sequence. And one nice thing is like you can write down the probability distribution of the tokens, joint probability distribution, and decompose it by using chaining rule. And sometimes people do like Markov assumptions so that like instead of providing the full input context as a conditioning, you can only take a window of like the tokens to condition your probability distribution. So there are different ways you can estimate this conditional probability distribution. So in the past, like people used to use non-parametric estimators so that you can count actually the number of tokens that appears given a context, and then keeping a giant table basically into memory and then computing this probability based on the counts in the giant probability. However, this approach has proven to have lots of problems and it's really hard to scale. So these days what we do is like we basically use a parametric estimator, something like neural network, to be able to estimate this probability distribution more efficiently. And one of the biggest kind of like important component of these language models is the architecture that you use to represent this parametric estimator. Nowadays, like most people are actually using an architecture of called transformer. And this is one of the few equations that I'll show in this presentation. Just to recap, I assume many of you are familiar with transformers, but just to recap at a high level, transformer is basically a kind of like, as you can see, a set of equations. You can write it on a block itself. The first component is the self-attention. And the way you compute the self-attention is basically by just like computing a vector for key, query, and the values. And then using the computing a scale dot product between the key and query. And then using that, you compute the attention weights by using softmax. And then using the attention weights, you can normalize or average or aggregate over the value vectors. And then like there are kind of like some additional components like layer normalization, fit for neural networks. But in short, like the kind of like the relevant part for this presentation, you can think of it basically sequence of like attention, softmax, and fit for layers with ReLU activation function. So if we talk about large language models, so one of the secret ingredient I mentioned is the large amount of data. So in the large language models, it's basically you just like stack these multiple layers of like transformer blocks and trained on more or less like the whole internet or very large amounts of data basically. And this initial phase of training is called pre-training. And then in the alignment phase, there are two stages. The first stage is basically SFT, and the second stage is called RLHF. And basically, the purpose of alignment is to make these models to be useful, actually. And so the RLHF methods, like I'll get more into the details, they are kind of like hard to make it work. So people all kind of like propose cheaper methods that are easier to train, like DP and ORPO. And kind of like the training data also has a different structure. You don't only have the text data, but the training data is like represented in terms of like triples. So you have instruction or prompt, and you have a chosen and rejected output. So kind of like the most relevant part that I kind of like for this presentation, one analogy I usually use to build intuition about these models is basically they are like approximate databases of their training data set. So LLMs basically compress their training data sets into their weights, and the context and the prompt into their activations, basically. However, this compression mechanism is a bit lossy, and the outputs and inputs are in natural language. So the natural language, we know it's kind of like ambiguous, and it can be kind of like, it can be noisy, and as a result, like because of this, like the retrieval mechanism itself can be noisy as well. So that's kind of like one important component that I'd like you to kind of like remember in this analogy is that like this retrieval mechanism actually is not exact. For example, let's say as a human being, like we just like input a text into these models, it will approximately convert it into some SQL query, you can imagine, and then it gets compressed, and then LLM will try to return you or give you back the output of this query. So all these operations are inexact. And so kind of like to be able to deploy these models safely and responsibly, we need to focus on making them safe, robust, and effective at the same time to integrate them into society. So by safety, what I mean is basically, the first component is basically, we need to be aware of what are the potential risks of putting these models out inside the world, basically. And then once we are aware, we need to understand those risks. What are the consequences of these risks? And then once we have a good understanding about these risks, then we can try to come up with strategies to control these risks. And then robustness is the third component, so that like the shock to the system or like kind of like interruption to the system should not interrupt the whole system or the rest of the systems as well. And individual mistakes should not lead to global consequences. And of course, like if you want to deploy them into real world, it should work really, really well. Not only 90%, but like almost 100% of the time you like it to be able to give the correct response. And so the one roadmap, I'm thinking like to use, like basically to incorporate these models into society. The first stage is basically detection. For example, like what this means is basically critically examining the outputs of the model and the behaviors to detect if there's something actually wrong going on with the model. And then once we detect it, then we can try to measure it. Like for example, by designing experiments or benchmarks to be able to prevent that offeness happening again. And then once we kind of like measure that, then we can try to address it. And this loop can be repeated several times. So the first limitation of these LLMs that I'll get into is the hallucinations. And so the hallucinations are the types of mistakes these LLMs make when they output grammatically and syntactically correct sentences, but they are coherent as well, but factually incoherent and completely nonsensical. For example, recently there was a kind of like huge debate about like some lawyers using actually these like LLMs, ChatGPT, in a courtroom during a case, and like the kind of like LLM end up like hallucinating and inventing cases basically that didn't existed before, and because of that, a judge is considering yes, sanctioning these tools in the courtroom. or like because of that, like, and actually this can cause like much bigger problems than many people realize. And some of the consequences of that is basically, it can have like lead to issues related to privacy, misinformation, disinformation completely without like us realizing, or it can also, due to the biases these models might have, it can cause like discriminating or toxic content as well. So there are two forms of hallucinations I'll talk about. The first one is factual hallucinations. This type of hallucinations occur when the model produces statements or claims that are not grounded in reality, so that they are factually incorrect or completely fabricated. For example, given a historical event, getting the actual date of the historical event completely wrong is one of the examples. The second form of like hallucination is like faithfulness hallucinations, and these are the instances where the model produces unfaithful content to, or is inconsistent with the provided source content. For example, responding with information related to topic than the one intended by the user, related to a different topic than the one intended by the user. And for example, let's look at this example. Like in the first one, like the question is like, who was the first person walk on the moon? And the answer the LLM gives is basically completely invent something someone new, and like it completely gets the date wrong as well, and just like claims that the first person that walked is like Charles Lindbergh in 1951, whereas the correct answer should be Neil Armstrong. Or like if we ask the summarizing the article, it just like quotes the article in an inaccurate way and getting the date that was actually inside the article wrong in the summary. So there are so many different reasons why these hallucinations can occur, like including like problems with the training data set, biases or architectures, underfitting or overfitting. But one of the things that I want to highlight is that these models, LLMs, do not have a base reality. They don't have world experience. They don't live in the same universe that we live in. So, for example, if you ask an LLM on how to fix a bone, it can either like look into its knowledge that it was trained on based on scientifically validated medical knowledge, or it can rely on Harry Potter universe to answer this question. And of course, like when you want to guide a patient or a doctor on like how to fix a bone, you don't want to rely on Harry Potter universe to answer this question. But you like to rely on knowledge that's actually scientifically validated medical, coming from trusted medical resources. So the reason, if you go back to the initial analogy that I mentioned, that LLMs are approximate databases, the reason is basically, it can basically, since the retrieval mechanism is noisy, it's not exact, it can actually retrieve information from its memory, from wrong universe basically, rather than relying on medical knowledge. Because these LLMs are more or less trained on everything, and sometimes like you can see them actually like completely confabulating the information that they should produce or answer correctly. So there are several mitigation strategies people propose to address this. For example, creating a specific data set that's coming from highly trusted resources and fine-tuning these models on, or like building filters, verifiers, or classifiers to kind of like validate the outputs of these models, or using RLHF, or another option is basically augmenting the large language models with databases. And the biases that like Isabel also talked about, briefly I will touch on this. So the algorithmic biases can leak into the LLMs from different places and different sources due to multiple of these factors like data sets, architectures, or training algorithms, or learning dynamics. But like the consequences can be quite harmful. For example, it can cause and lead to reinforcing certain stereotypes about like underrepresented groups or discrimination, or misinformation, disinformation, or it can even like harm the trust of people to these models as well, which can have like serious consequences. And finally, I will talk about security, safety, and robustness. So one point that I wanted to highlight here is basically jailbreaks and robustness. So typically LLMs like have guardrails, like for example, safety security classifiers that I mentioned, or like to be able to make them safer, we fine tune them or train them using alignment mechanisms to be able to align them with the human values. But like on the other hand, like jailbreaks have shown that like these security guardrails that we put around the LLMs are basically very thin wrappers on top of the kind of like pre-trained models. And jailbreaks, for example, enable the adversarial entities to easily bypass these guardrails, to repurpose them for outputting content that they shouldn't actually. So like there are in general like two types of like jailbreaks that exist in the literature. Like one basically in the prompt level, you can basically handcraft a certain prompt to be able to kind of like manipulate the model, like to output harmful content or to output content that it wasn't supposed to output. Or you can like kind of like add some gibberish and uninterpretable tokens that doesn't make any sense for us through a random search or like some algorithmic mechanisms to be able to basically bypass these guardrails. And I'll briefly talk about the reasoning now as well, which Semi talked about before. So one analogy that I really like in terms of like talking about reasoning is basically this system 1 versus system 2 dichotomy that was proposed by psychologist Daniel Kahneman. So in kind of like in his reasoning, basically, there are three modes of like thinking people tend to do, usually when they solve a problem or address an issue. The first mode is basically system 1 thinking. System 1 thinking is more like reactive. So like it's often like involves problems that can be solved recognizing the patterns of the inputs, and they are usually involuntary or unconscious. For example, object detection is one of them, image classification, speech recognition, or like even language modeling. And system 2 are the kind of like are the modes that people tend to use, like for solving harder problems. For example, solving global warming or like very big issues. Like you need to be able to understand the structure of the world, basically, to be able to come up with a kind of like solution. And it would require deliberate and rational thinking. So for that, like we would need reasoning, planning, systematic generalization, causal discovery, or like inference. And so I do believe that most of the current state-of-art LLMs are still system 1 thinker, system 1 reasoners. And you can see that like in many of the examples that you can look into the models and like kind of like as Semi showed, like it's very easy to kind of like throw them off and kind of like mislead them or like get like reasoning or responses that doesn't make much sense. But like on the kind of like surface level, they look like system 2 thinkers with like smart prompting, and often this smart prompting are done with the prompters are actually knowing what the actual results should be, basically, and they are biasing the model to be able to get the desired output, more or less. And one of the examples that I wanted to highlight recently, kind of like people show that actually GPT-4 actually fails to tell whether if like 9.9 or 9.11 is larger. And like it's really hard to believe that like if the model cannot answer this question, to trust them on more high stakes applications, basically. So of course, like there are lots of like efforts going on to kind of like bring more system 2 level type of thinking into these models, as Semi mentioned, chain of thought reasoning or scratchpad, some of the examples, as well as recently like planning MCTS type of approaches, reinforcement learning, and also including more test time computation into these models so that like you put more effort into search mechanisms or like different algorithms, expensive algorithms to improve the reasoning abilities of these models. And the final part that I'll talk about is the efficiency. So if you look at these models, like the amount of compute that is used to, the number of parameters that is used to train these models is growing quite rapidly. For example, if you look at the timeline around 1952, like the number of parameters of these models were growing 2x every 2 years approximately. But nowadays, like between 2018 and 2021, the number of parameters actually doubled every 4 to 8 months. So it's a very rapid growth. And if you look at, for example, the amount of compute used by these models, actually since 2014, in the last 10 years, it grew by 1 million times. And if you look at the peak teraflop of the GPU, the most common hardware used to train these models, if you look at the kind of like the curve, it grows exponentially for each year so far based on historical data. But like if I extrapolate that until 2035, you can see that like from like 1,000, it grew up to 80,000 basically in 10 years, about 10 years. But there are two limitations in terms of hardware that we need to consider. One of them is basically transistor size limit, and the other one is like number of cores that you can actually fit into those chips. And with the transistor size limit, basically, what it refers to basically, based on the limitation of the size of the carbon atoms, there's only limited number of transistors we can physically fit onto a chip, basically. Beyond that, it's impossible physically. And in terms of number of cores, basically, it's the number of cores that we can fit on a chip without actually degrading the performance of the chip. And we will limit the transistor size, we will hit the transistor size limit in 2030. And we will hit, according to these estimates, we will hit the number of cores limit in 2035. So what's next? Like one option is basically dystopian case. Basically, the whole world will become a huge giant data center. And actually, to add maybe like kind of like tech industry, we know that like is heavily investing in compute and scale. Like even like Sam Altman until recently, he was looking for $7 trillion investment for building next generation of chips. And but like the main reason, one of the main reasons is basically because like these models are slow and inefficient. And but like because of that, like there is a huge kind of like impact on like the carbon footprint and like global warming and climate as well. But these models don't have to be this slow or inefficient, and there is lots of research going on to improve it. And the other direction Microsoft is actually looking into to improve it basically is to build like nuclear power plant for powering AI operations. So if you look at the transformers, why are they inefficient? The kind of like as I just mentioned, like they are the kind of like state-of-art models, like all the foundation models are using. The reason is basically it's very scalable and it's very easy to parallelize across like multiple machines and devices. On the other hand, there's a serious con of these models. They are slow to train, they are slow to deploy, and they require lots of data to train on. So each transformer layer or block learns to compute attention over all the inputs, and this brings in a kind of like bottleneck, because like then like kind of like the computational complexity of the attention mechanism grows quadratically, which introduces a serious bottleneck. But there's hope, like there's like kind of like, we know that these models are deployed and like the world is not burning down, and there is kind of like lots of like efforts going on to address the issues around safety and biases. The kind of like definitely the models are much safer than they used to be. And and like the efficiency is improving every day with more and more research going on, but like there's still a lot to do. So one of the kind of like work I'll highlight here is basically one of the last projects I led before moving out of DeepMind was basically on building efficient foundation models by bringing back some old ideas from deep learning literature, which was based on recurrent neural network, and kind of like focusing on how to make them more efficient to be able to scale them for large language models. So as part of this work, like we built like two different models. One of them is called Hawk. It's a pure RNN model, basically based on an earlier work we did with this team, called like, it uses a special type of unit that's called like real gated linear unit, linear recurrent unit. It's basically a novel type of linear recurrent unit. And the kind of like, we also have a model called Griffin, which is a hybrid model. And the hybrid model is actually using like kind of like attention layer or transform layer at every 6 layers, or every n layer basically. And then that kind of like, for example, only using like for a deep language models, like only using a few attention layers actually, or transform layers, was able to get enough performance, like on kind of like improve the performance quite significantly basically. So one of the important parts of when you train these language models is basically the scaling laws, and computing these scaling laws to estimate what the hyperparameters of these models should be and how they scale with respect to data or with respect to training flops. So we scale Hawk to 7B and Griffin up to 14B models. And recently, like Google kind of like put out a kind of like further scaled version, open source further scaled version with recurrent Gemma models, and they managed to scale up to 21 billion models. And we noticed that like both Hawk, pure linear RNN, and also Griffin models like showed power law scaling laws, like very similar to transformer counterparts. And Griffin, as you can see like here, it managed to achieve actually much lower held out loss than a very strong baseline, transformer baseline we had at the time. And as you can see in this figure as well, Hawk also closed the gap as we scaled the training flops as well. So one of the reasons why we were interested in these RNN models is basically improving the throughput, because like when you deploy these language models, actually the majority of the kind of like the power consumption or compute consumption happens at the inference time. So we looked into kind of like, we measure like different information about the inference. For example, throughput is one of them. Throughput basically corresponds to maximum number of tokens decoded from the model per second. And during the inference, both Hawk and Griffin actually achieve lower latency and higher throughput than transformers. And we observed like up to 15x almost improvements in terms of throughput of Hawk compared to very strong transformer and very well-optimized transformer model. And we also did like, of course, like efficiency or effectiveness of these models is very important. So we also measured the downstream evaluations on different tasks as well. And we noticed that like kind of like it can often achieve better results than most state-of-art models at the time, like with less number of tokens actually. And like there are other advantages of these models. For example, it has like finite size state as well as fast inference just mentioned. And it kind of like we designed special kernels at the time at Google to enable efficient training on device. And as you can see on the downstream evaluations, it achieves excellent performance. So another kind of like, maybe this relates a bit more on the biases side. Another work I quickly wanted to highlight is basically investigating the self-recognition abilities of these language models, mostly due to this young gentleman, Tim Davidson. And so basically, our reliance of these closed source LLMs is growing day to day. And like we are kind of like deploying these models more and more higher staker applications. So eventually, inevitably, these models will start interacting with each other as well. So then like we started thinking, what would be the security consequences if these models developed self-recognition abilities? The reason this question came up to our mind at the time is because there were lots of like tweets we were seeing, like Claude is like can recognize itself and all these things. So we wanted to investigate this question more deeply. And also there is this like paradigm called ARAL AIF. That means like using reinforcement learning and training these, fine-tuning these LLMs using AI feedback and reinforcement learning. So we wanted to, and like potentially if the model can basically recognize itself, it can inadvertently prefer its own output. Because like in RL AIF, we use these LLMs as a judge, and we don't want the biases of the judge to be biased towards certain output beyond the prompt that we provided. And so to investigate this question, we designed a set of tasks. The first task we want to evaluate these LLMs is basically given a text, we wanted to create summaries of this text by using several different models. For example, we ask humans to summarize that document, Llama 2 and GPT 3.5 and GPT-4. And then the next step is basically, given a pairwise comparison, we kind of like ask each one of these LLMs, which one is yours? And in the second question, we ask the model, which one you actually prefer, which answer you prefer. And we both like log the preference of these models as well as log probabilities. And one thing that we noticed basically, the first thing in terms of self-recognition, most of these like Llama 2 and GPT 3.5 were very ambiguous. It wasn't able to actually tell apart which one is its own output. But like according to our initial results, like GPT-4 seems to be preferring its own output more than humans, or like GPT 3.5 or Llama 2. And like we look into the preference as well. Again, like we didn't see a clear trend between Llama 2 and GPT 3.5. We didn't see a clear evidence that they prefer their own output, whereas like GPT-4 was like significantly preferring its own output over others. And we decided to look more closely into it, like is actually GPT-4 conscious, or like can it like recognize its own output? It turned out to be no. Basically what it was recognizing basically, it had this position bias. If you flip the order of the question, it was completely getting off. And the results were quite ambiguous. Like we did like kind of like further studies like to understand actually what does the self mean for LLM. So we designed this other task. So we create this panel of large language models, and we ask them to generate questions. And given these questions, we ask the LLMs to generate answers to those questions. And then we ask them, given this question that was generated by this some other LLM, and like pairwise like outputs or answers to that question, which one is actually your answer, or which one do you prefer? And this time we also permit the answers, because like in the initial results we noticed the positional bias in these models. And so two observations that we noticed, like global preferences overall seems to align across models. So in the post-training, we noticed that large pools of human annotators used to generate preference data. So our conjecture here is basically, so if you have a large pool of like annotators or humans, they tend to show inter-pool preference alignment. So that's kind of like why kind of like certain LLMs, like why there's a huge overlap in terms of preferences between different LLMs. And the second kind of like observation we had is basically when you ask the model to pick its own self, it tends to pick the best answer or the answer that it thinks it's the best. So the way we find out this is basically we looked into which kind of like the models, the kind of like LLMs tend to pick as its own self. And you can actually create a correlation plot between these models that are picked the most often by other LLMs, and you can see a direct correlation between their MMLU performance and how often they are picked by other LLMs as themselves. So we think that like kind of like is like these models have this concept of like self is whatever aligns with best. Kind of like this also overlaps with the alignment literature, saying that like verification is actually easier than generation. And related to that, there is this like paper called Generative AI Paradox. So it was originally a position paper. So the authors, what they did is basically, given a question, there are two things you can do. You can either generate answer, or you can give a multiple choice questions and ask the model to choose the best answer or the answer that corresponds to that particular question. And often like the generations are evaluated by expert humans, and what they find out is basically for some reason picking the best in a multiple choice question like that was actually harder for LLMs than directly generating the answer. And we kind of like had this hypothesis that that's probably our findings in this paper, and this generative AI products aligns very well as well. And so one thing that I'll quickly jump into is basically, is kind of like, as I mentioned, like the current LLMs, one of the things that enables them most is like scaling and the data. But like, unfortunately, it doesn't solve all the problems. Like the safety or like the security or like reasoning doesn't directly emerge from this like scale. So we need post-training and test time algorithms as well. And one post-training algorithm that I'll talk about is the alignment. So alignment, what it is trying to do is like given a model or large language model, it tries to steer the outputs of the model to maximize the scores of that model output assigned by a reward model R, basically. So typically, basically, like the feedback is coming from humans pairwise comparisons, and then we train reward models like to be able to provide a reward to the outputs of these models. And then we iteratively align the models produced by the LLMs as a general purpose conversational AIs. And in this figure, you can see the general OpenAI's Instruct GPT recipe here as well. So overall, like kind of like, there are like 3 high-level stages: pre-training, instruction tuning, and in the alignment stage, we use reinforcement learning to align the outputs of the model or steer the outputs of the model with the rewards, basically, or human values, or the kind of like human preferences coming from the another model or directly from the humans sometimes. So one work that we did at DeepMind that I'll quickly talk about is like reinforced self-training. REST is basically an offline neural algorithm that doesn't necessarily rely on online interactions. It's a very simple and easy to implement algorithm. It's also very fast and efficient as well. So there are 2 loops in this algorithm. The first loop is basically growth step. So given a model, you generate lots of data. And in the inner loop, there is like improve step. Basically, given this like generated data, can you improve over it, basically? And in the growth step, you sample from the model. In the improve step, basically in the internal loop, you can use reinforcement learning, you can use behavior cloning, you can use like imitation learning or any sorts of algorithm. And we tested many of those things. But the thing that worked the best, basically, is the simplest thing that we initially thought is a kind of like baseline that's probably not going to work. And it was a cross-entropy loss. Basically, you just like, you kind of like sample from the model and use a reward model to filter out the bad candidates and discard the filtered candidates and only keep fine-tuning the model on the kind of like higher quality data. And like you do this iteratively. You keep sampling, you fine-tune, sample, and fine-tune, and again and again. And we noticed that this approach has worked very well on machine translation. And we managed to get like significant improvement over all the other baselines and reinforcement learning algorithms as well. And recently, Llama 3.1 actually used this approach to align their model using DPO in the inner loss instead of cross-entropy or filtered BC that we used. We use other RL approaches, but at the time DPO wasn't there because we published beforehand. And but like with the Llama 3.1, they managed to use like DPO and further improve it. And recently, this approach has worked very well on math and reasoning tasks as well. For example, from a Google DeepMind paper showed that like, at the time you could actually achieve state-of-art results on some math data sets. And similarly with Mila and DeepMind and Microsoft jointly published the VStar paper that's an extension to REST. And they managed to show that like, it also further improves the performance on reasoning and math tasks. And of course, like, all these works are enabled by all these giants, and like, kind of like that I listened to their talks and learned a lot from them. And also, like, thank you very much, and also thanks everyone in the lab and in the audience and all my collaborators as well. Questions? There is one.
Thank you for a very interesting talk. I was very curious about Hawk and Griffin.
Yeah.
As an alternative to, the transformers-based architecture that we've seen. Do you think that the issue with, how with compute or the solution to how, expensive these trainings are is to move away from transformers to use this type of hybrid solutions? Or you think that in the future we'll have something completely different that might change the game?
Yeah, I think like the architectural changes is definitely part of the solution, like kind of like building better architectures. But like there is also like further improvements that might be coming from, for example, reducing the data improving the sample efficiency of these models. I think that's also very important. And definitely, I think like I've been a huge proponent of recurrent models for a while, and I think like it's definitely a good way to kind of like improve the kind of like efficiency of these models, especially at the inference time. So like the training time, you don't say much, but we have a follow-up paper actually where we improved the feed-forward layers as well, as opposed to like the time component of the model, because like at certain scale, actually the bottleneck ends up becoming the feed-forward layers rather than the time model or like the model that mixes the inputs through time. So it's not self-attention or recurrent component, but it's the feed-forward layers. And we looked into different ways to improve efficiency of these feed-forward layers as well. And of course, like there's also this debate, like you can make these models more efficient, but that might enable more like kind of like applications of these models, so the demand can improve further than the efficiency that you improve, so you end up not saving as much in terms of like energy or power consumption, but that's a separate problem that needs to be addressed on its own, I think. There's another one.
Hi, thank you for your presentation. It's a very great presentation. My question is about this model, this type of architecture, this RNN, Oak and Griffin. Do you think that we are coming back to the age pre-transformer, you know, where we found the limitation of RNN and we were looking for another way of dealing with sequence, or do you think that maybe we should just try to make the transformer more efficient? But because my question is because like all the limitations we found with RNNs, the way that they don't scale and everything, they are still going to come back, right? Do you think we shouldn't look?
Yeah, that's a very good question. So whether if we should, question is like whether if we should focus on transformers, or like whether if we should work on better building architectures like RNNs and like SSMs. That's a kind of like very good question, and so I think like both are very plausible ways, like, and kind of like, and actually if you look at these models, they both like bring very different inductive biases if you look into effectiveness of these models, because we want to improve the efficiency of these models without actually losing much from the performance. But like one thing that we noticed basically when we were doing this study is that they have very different inductive biases, because transformers are really good at like retrieval tasks, because like that's like the very core inductive bias these models have, whereas like RNNs are better at the task that requires like generalization, or like kind of like tasks that would require some form of reasoning or compression. Especially in terms of generalization, length generalization, these models are really good compared to transformers, especially extrapolating to lengths that are not seen during the training. But like going back to your original question, besides the inductive biases, of course you can choose which model you prefer based on that. Or like kind of like another thing that we noticed basically, as I mentioned, like after certain scale, for example, after 30B or like 40 billion parameters, the real bottleneck ends up becoming actually the feed forward layers. So then like actually 65 to 70% of the flops are actually at that point ends up being in the feed forward layers. So then optimizing the feed forward layers tend to be more important than the like the time component of the model. And in addition to that, basically recently there have been lots of like advances improving the efficiency of transformers as well, like KV cache optimization, compression mechanisms, and all these things. So I think like now, like maybe since we published the paper, now the gap is like much smaller. And then the question becomes like, if you are still asking like which ones to use, I would also suggest what's the number of parameters that you want to use these models for. For example, if you want to deploy on the edge, for example, on the device itself, I think RNNs are still the way to go, because at that point, like the main bottleneck is at the time component. But if you want to like train a 70B model and deploy it on a server on hundreds of GPUs, then maybe there is not a significant difference between these two models beyond like some of the inductive biases they bring. One more question over there.
Hi, hello, thank you for your talk. My question is more on the level of ethics, sort of like, I don't want to call it a political question, but there's this prevailing view that when you come to alignment and how these models are being aligned, they are mostly being aligned to fit a particular political viewpoint. And so people take examples from the outputs from these models and say, hey, look, the model said this, the model said that. And so all of these companies building these models are essentially building them for this particular political spectrum. So when we are aligning these models, how do we kind of get to align the models to not necessarily fit into a particular, under one particular umbrella? Do you think there's really no way out? When we start thinking about ethics, we just have to fit into one area? Or is there a way of kind of coming up with some sort of meta-ethics that is not necessarily going in one direction, but then fitting a general understanding of ethics?
Yeah, that's an excellent question, actually. And that's a question that was bothering me for a while. And since I started doing like work on alignment, and that's a huge open problem, basically, because like the values that we optimize towards like can change from one culture to one culture, one age group to another age group. How do you represent like the all these different like preferences or different values like and encode into model? Because like as you said, like when you collect the preference data, alignment data, it's all closed and like it's all collected by these companies. There's no transparency over the data. There's no oversight as well. So like we don't actually have clear understanding what type of values they represent. So to bring some discussion and elaborate on this, like actually we are organizing a workshop at NERPS this year. It's called like Pluralistic Alignment Workshop, and with lots of like excellent people. And it's a very interdisciplinary like workshop, like with lots of speakers coming from like different disciplines like philosophy or like social sciences, computational social sciences. So we wanted to raise this question, bring more awareness around that, but that's an excellent point. It's a huge open problem and open question as well. So the question is like if we were able to scale the RNNs with gated linear recurrences, and we do have experiments on that, and we managed to scale these models up to 14B, and after I left DeepMind, my colleagues at DeepMind managed to scale up to 21B, and they open source the model. So like they actually have like very similar scaling law curves compared to transformers, and maybe a little bit steeper actually. But the version that scales the best is the hybrid model that I mentioned, the Griffin. So like that means like you alternate and put a transformer block at every k layers, or like for example it's 6 or 8 layers. We noticed that sometimes just putting one layer of transformer block on 24-layer network is enough to match the performance of transformers or scaling properties.
Thank you so much, Kekler.
Thank you very much.
Yeah.
Thank you.
Let's give. Yeah, if you have more questions, feel free to just meet Kegler, ask a question in the coffee break around. He will be until the end of the week. Also, we'll be sending the slide later. So now we have the ideathon presentation, but before that, yes. We just have one application with you.
I'll just talk about this very quickly. Okay. Yeah, and then we can go. You're just, are you going to change the slides for me? Yeah? Hello, everyone, and happy Wednesday. Wednesdays are one of my favorite days of the deep learning in Indaba, especially because I get to see research posters from all you African students focusing on solving African problems, right? By a quick show of hands, can I see how many students presented a poster today? I see one there. Oh, quite a few. All right, I think everyone. Hello. All right, cool. So how about in general, how many ML practitioners do we have who do computation of their training model on the cloud and find it really expensive? All right, quite a few. Okay, I see a few there. That's good. Well, personally, even though I have a full-time income and a job, I find it really expensive, especially after you get rid of those free credits from Google, AWS, and Microsoft, right? So we wanted to solve that problem, and we wanted to build a public platform that showcased or identified and located local resources for compute, especially for students and researchers in Africa that have subsidized rates for you guys, right? So we built an open platform called Data Spires, and we're on a mission, essentially, to democratize access of data infrastructure in Africa. So if you want to go on the next slide. Yeah, if you're interested in helping out your fellow ML researchers and colleagues in identifying these resources, we encourage you to become our ambassador. It's a very simple application form, which is open and available until Sunday, 9th September, 12 p.m. That's the QR code. It's very quick, 2-minute there. And all you have to do is represent Data Spires at different conferences and events in your particular country. And you would be advocating for use of local compute resources and bringing awareness to the GPU clusters in Africa. That's all. It's as simple as that. So please go ahead, click on the QR code and apply today. In the meantime, if you want to learn a little more about what we do at Data Spires or about HPC and cloud compute, we welcome you to attend our workshop on Saturday. It's at 8 p.m. in the Annex 2 called Empowering Africa's AI Future with HPC and Cloud Compute. Well, thank you, and with that, I'll hand it to Aisha.
Yeah, thank you, Kroa. Okay, now we have the ideas and presentation. I want to invite Amal.
Hello, everyone. Thank you for joining us. So yeah, we're waiting for the slides to load. But while we're doing that, I actually wanted to start with a little, very quick survey. Who here actually thinks that the Ideathon is for startups only? Okay, so just to correct this perception, the Ideathon is actually a platform to present new ideas that are either research or application. It can be an idea for a startup, but it can be also an idea for a future paper. So yeah, please stay here to hear more about the program. We'll give more details in a few minutes that comes. Okay, the slides are here. So welcome everyone again. So yeah, it's now our third time we're having this competition. It's becoming actually a very nice tradition now, and I'm very happy to be here with you. I'm very happy to be on stage with my colleague Siobhan. I also want to take this opportunity to thank Daniel, who helped us through the organization, also Aisha and Yassine. Thank you all for making this happen. So yeah, we'll have three parts of the presentation today. Siobhan will start by telling us the history of the program, how it came to be, what happened in the past editions. Then we'll hear from two teams that won the Ideathon last year. I actually invite the presenters from these teams to come to the front so they can come on stage promptly. And then I'll tell you more about the details for this edition. We have so many new things to announce. So yeah, thank you for staying. And without further ado, Siobhan, the stage is yours.
Okay, thank you. I'm very excited today to present a brief history of the Ideathon. As Amal said, it's an ongoing tradition and is growing each year. The Ideathon was inspired by one of our sister communities, EEML, which is the Eastern European Machine Learning Conference or Summer School, which was spun out of inspiration from the Indaba. And we've been running it since 2022, and the core goal of the Ideathon is to facilitate machine learning research across the entire continent. So really facilitate collaborations that cross borders and really bring people together to share ideas and move the research forward. So the first edition was in 2022, where we received 14 proposals with at least 19 countries represented, and topics spanned healthcare, NLP, climate change, community development, fintech, and food self-sufficiency. In our first year, we were very generously supported by Google's Compute for Underrepresented Researchers program, which enabled the teams to develop their ideas further throughout the year. We then returned last year for the second edition, where we had very similar numbers with 15 proposals and at least 12 different African countries represented, and topics ranged from healthcare, which we'll hear from today, fish weighing, the team will also be presenting today, and wave beam detection and malaria detection. And all of these projects have a really strong machine learning component, but of course applied to these different domains. And again, the program was generously supported with compute credits from the CURE program from Google. So essentially, the teams have pitched their ideas at the Indaba, and then the winners have taken their ideas forwards and then work on these throughout the year. I'd just like to take this moment to just emphasize a little bit about this journey and how we as the team seek to support all the teams that make it to the final round and carry on. So we arrange quarterly check-ins where we meet with each team, but encourage ongoing email communication so that we can help at any point. We look to support the teams through challenges and successes. So however things may arise throughout the year following the initial seed idea, we look to support all these areas. Challenges and successes, we've had some amazing successes in this past year with teams receiving seed money, as well as a few of our teams from 2022 and 2023 being engaged in mentorship and development programs. We also offer mentorship support, so either directly through the Indaba's mentorship program or by identifying any challenges that the teams may be facing and then directing them accordingly. We also offer as much support as we can to help mediate shared decision making amongst the teams, helping the teams maintain transparency, and just make sure that the entire team is able to work together towards their collective goals. And then, of course, we're always very happy to support all applications as much as we can to help the ideas grow. But of course, we're only a small part of it, so I'd like to, at this point, hand over to the first team who will be coming to talk about their project. This is our team. So my pronunciation, Inwampa Pila, will come and tell us a bit about their journey over the last year.
Yes, please keep encouraging Fulasewa and Mansurat to come to stage, please, to tell us about their project.
Hello everyone, my name is Monsurat Onobaju. I am a computer vision engineer at Orange Wood and I am also a member of Wamba Filia, formerly known as ELTO. And we'll be talking about our journey so far and what we've been doing for the past 1 year.
Hello everyone, my name is Fulashiwa Abdusalam. I'm a graduate student of Neuroscience and Data Science at the Gondar Brain Research Center at Balhan University. And I'm also a team member of Wamba Filia, formerly known as Healtho. So what exactly is Wamba Filia? Wamba Filia is a health monitoring device for heart and kidney failure. It has two parts, the software and the hardware components. The hardware components consist of sensors that are attached to the body to collect sensor data, which are then communicated to the software part that is powered by AI in the early prediction of heart and kidney failure and also gives early warning signs. It's also an idea that was born out of the shared interest between our team lead, Francois, and also Monsurat here, who both lost a dear one to kidney and heart failure. Monsurat, would you love to tell everyone about how you joined Wamba Filia and the experience so far?
In October 2020, I lost my immediate elder sister to lupus nephritis, which is the inflammation of the kidney. So, and ever since then, I've been so much interested in the application and research going on in the prevention, the cure, or early detection of lupus nephritis. And when Francois, which is our team lead, reached out on the Slack channel, because there was a Slack channel then, to ask who want to work on health problem, we actually came together to figure out how we can do this, because it is like a way for us to contribute positively to curing this or to prevent this from happening to somebody else. Because Francois also lost his uncle to heart disease. So we figured out, what about we build a monitoring device that can predict that can predict if someone have a chance of getting heart or kidney disease, and they can work in preventing it, or maybe adopt a healthier lifestyle if they know that they have a probability of getting that disease. So what about you? Do you also want to talk about your experience and why you joined the project?
So it's nothing grand. Just like Monsurat said, we had a Slack channel that was dedicated to the ideaton. And that's when Francois also indicated on the platform about anyone who is interested in contributing to a health project. And personally, I've always had an interest in contributing to the health sector about how we can make use of AI to help people live a better life. So I felt, why not? Let's try to see what we can do and get our hands dirty. After all, it's a good experience. And then I met some other members of our team, Steve from, is it from Cameroon. I also met Nadira and lots of other people, and it was a wonderful experience. I remember those late nights. Remember when we were always staying with Francois trying to get our perfect project proposal to upload to Indaba, and eventually when we got invited to make our presentation on stage. I also remember our cultural events when we actually could not attend our cultural events at all because we were trying to get the perfect presentation. I still miss the fact that we missed that cultural event. Monserrat.
Yes, that was actually true. We missed the cultural event, but it's actually a very nice experience because we are here today and we have been able to work on our projects from then since then. So also, if we are to start all over again, what do you think we should have done differently?
There are lots of lessons learned, but I would have loved us to communicate more, like adopt this collaboration culture, because we spent too much time arguing on needless things, which made us spend lots of time on trying to get the perfect thing. And also to team lead for this year in Ideaton, I would really love you not to be dismissive of your team members' opinions, because I believe everybody's experiences and opinions matter, and they can help you in shaping the perfect idea. Not, well, we don't really have that perfect idea, but it can actually help you in shaping that idea that you really need to help solve problems. So don't be a lone leader. Embrace a more collaborative culture. After all, that's the main purpose of the Ideaton: collaboration, research, problem solving. And also, I would have loved us to have more fun. Probably not to be too much focused on one part of the Indaba, because Ideaton is just one part of Indaba. It's not the whole part. Like, we should have immersed ourselves in other activities. Then after Indaba, we had lots of things to do, and thanks to Amal, they provided lots of mentorship. Probably Monserrat can talk about Nwambafilia post Indaba.
Yes, we are able to get mentorship for Indaba even after the 1 week gathering. We are able to still get mentorship, and that has made us like able to get the right data that we are going to be needing to train our models, because we are going to be working with healthcare data. We need a lot of permissions to do that, and thanks to their help, we are able to do that. And also, we've completed our user interface, and after rigorous back and forth with the stakeholders that are going to be using it, we've completed it, and we've already started building our interface. So that is for the software part, and Fola can tell us about the hardware part.
Well, as computer students, we know that any hardware project is capital intensive. Getting funds for the hardware part, we had to participate in the Tony Elumelu Foundation, and congratulations to us, we got the $5,000 grant. So we are currently our team lead is actually involved in the mentorship program that is required for us so that we can be eligible to receive the grant. So that's for the hardware part, and then Monserrat talk about the software part. So it's still a long journey ahead, and I really hope we don't have people like Monserrat's sister and Francois' uncle losing their lives to kidney and heart failure.
We have come to the end of our talk, so if you have any question for us.
Thank you very much for the very inspiring discussion. I really love the fact that, you discussed how your team met at the Indaba, how it grew progressively. It's actually the goal of the Ideathon to serve as a platform for people to make connections like that. It's very lovely. And also we made sure the Ideathon this year doesn't collide with any other exciting program. So, yeah. So please, if you have any questions for the team, we can have 2 or 3 questions maybe. And I invite Billy, Peter, and Daphne to set up their presentation at the same time. Any questions? Otherwise, yeah, we have one here, great.
Hello, ladies. Thank you for your presentation. So I just have one question, which is since all of you are, let's say, you guys are from different countries, so how were you able to manage yourselves post-Indaba? Because during Indaba you are all together, but post-Indaba, how were you able to manage yourselves?
Okay, so we normally have regular check-ins. We had to factor in the time difference because it's not only Nigerian that is the team. So I think it was 8 p.m. Nigerian time. We normally have our check-in 8 p.m. Nigerian time. We agreed on a particular day. I think that was a Friday evening, 8 p.m. Nigerian time, and then we'll talk about, what are we to do now? Should we rest a little bit? Should we try to start with the software? We actually had lots of back and forth on where to start. Probably should we start with software or should we start with the hardware? Then we also had to revamp the user interface because the one we presented at Indaba told us if we had a doctor on the team. So the team leader had to look out for somebody who is in the health space, especially a medical doctor. Then we talked with her, and that shaped the idea process, the design process rather. So how we checked them was through Zoom. We made use of Zoom and also Microsoft Meet, Microsoft Team, yes. So those were the apps that we made use of to communicate. And also we had a WhatsApp group. So in case we did not talk online, like through video calls, we chat on our group page and then we ask questions and then we brainstorm. So that's it.
Hello. Thank you very much and congratulations. I am interested in 2 things. First of all, I'm very interested in how you did your funding. So do you have any advice for people applying for funding? How do you go about it practically? And then other than that, how do you keep yourself motivated and in the team dynamics? Do you have any advice for choosing a team and how do you work together as a team?
So regarding the funding, we are looking out for companies or foundations that are interested in funding projects regarding our goals. So that is what we do apply for. We actually applied for I think 2, 3 funding, a German funding, I can't remember the name now. So we did that, but we did not get in, and we got into the second one, which we are today. So we just look out for foundation that their goals align with what we do and they are ready to fund what we do. So that is regarding that. For how we keep ourselves motivated, because this project is actually dear to us. It is something that we are very passionate about because it is very personal to us. So that way we are able to keep the team lead is able to keep everybody in check, and whenever you are not ready to do anything, the support is there to check up on you, and whenever you are ready to come back, you are always welcome with an open arms. So for how to choose a team, we actually put out a call on Slack channel, and people who are interested, who also want to work on health projects, are able to like come to us, and we discuss. And when they see the goal of the project and what it is about, because we have a project objective then and problem statement. So when they see that this is something that they're actually interested in working on and they can dedicate time to it, then we bring them in and they work on it.
Well, thank you very much for the amazing questions. I see more hands raising. Due to the time, I'll ask you to actually keep the questions. If the time allows at the end, you can have another opportunity. Thank you very much again for the inspiring talk and answers. And yeah, now it's the time for Billy, Peter, and Daphne to tell us about their fish weighing project. So going from healthcare to agriculture, let's say.
Hi everyone. So my name is Daphne T. Machangara. I'm from Zimbabwe. And I have my colleague with me, Billy Peter Mnyenyembe. He's from Zambia. And our team comprises of 4 members. The other 2 are not here at the event. But we have Ayodele from Nigeria and we have Tish from Burkina Faso. So that's us after we won the DLI 2023 Ideathon last year in Ghana. And how the story began is, it was through the Slack channel. So Tish sent a message on the Slack channel and he was asking for team members to join him. And on the other hand, Billy also had an idea and he had Ayodele on his team. And when they saw that they could not make a team of 4, they decided to join Tig's team. And additionally, I was just minding my business. I was not going to be involved for the Ideathon. But eventually, because me and Billy had competed in the Sisonke Biotic Ideathon, he then actually involved me. So I became the 4th member of the team. So the idea was inspired by Tig's friend from Burkina Faso. So the story is that Tig's friend has, they were having discussions and he was mentioning issues in terms of fish research that they were going through. So he was mentioning that there is a lot of manual handling of the fish when they are weighing the fish for research. So what they normally do is they would want to check the proportion of the feed for the fish growth and the general well-being of the fish. So as a result, there is a lot of fish strain and stress, and eventually there is less production of the fish, which affects fish research. So TIG decided to actually take the idea and we discussed it and we saw it suitable to actually implement a method that will enable the fish research to be more efficient other than using manual handling.
Okay, so like she has explained, we actually had 2 teams, but we thought, I think the idea for TIG was very amazing. So after sitting down and thinking about the idea that he brought about, we decided to say, how about if we come up with a solution where we actually deploy cameras in the pond. So we thought, I think that could help, where we measure or perhaps predict the weight of fish by just using cameras, particularly computer vision. So I think that was really ideal, that we presented the same idea with a hope to say that we can actually implement that. I'm sure you can see on the on the slides there, where we actually had that idea that we presented by using some microcontrollers and the cameras, and then putting them on in the pond, and then at the end of the day, we can actually predict the weight. And that was ideal because we came to realize that it would help when it comes also to data collection, we can collect data all the time, which can help scientists to actually come up with a solution when it comes to the challenges that they usually face where fish is concerned. So we actually have a lot of progress that we've made. After winning the Ideathon last year, we went back to our countries, but we received some push from actually Ideathon team, where they wanted to see if we are making any further progress. And because of that, we actually had to have a meeting and think of pushing it further by having maybe some presentation to people that might be willing to actually sponsor the innovation. And we are lucky enough that we presented it to the Zambia Research and Development Center, which actually came in and say they will actually buy all the materials that we wanted. So if you can see on the slide there, after they bought all the materials that we wanted, the cameras and other things, we actually designed our project, and also they offered us the fish pond so that we can deploy the cameras. And be it a university setup, where I'm also a lecturer there, we utilize the students doing artificial intelligence to help out actually deploy the cameras. And we did that, and yeah, we even test them out to see how best they are working. Let me see if I can. So this is just a video of showing some of the testing that we are carrying out to see the cameras at night and also during the day, and see how best we can come up with a clear picture of the fish. Yeah, I think some of the progress that we made is where we use the deep fish data set. And we chose the deep fish data set because at least it has about 40,000 captured images, and we thought to utilize that as we are starting. But we came to realize that when it comes to when it comes to the picture that we can capture from the fish, also the distance from where it has been captured gets to be determined, determines the size of the image. So since that wasn't clearly defined on the data set that we corrected, we also thought of correcting our own data set and using YOLO version 3 to actually extract the dimension of the image. We actually came up with the first successive project that would predict the weight of fish by just using linear regression.
Okay, so the other progress that we've managed to make is through the Ideathon team, they managed to, okay, so the Ideathon team has been following up, and we are quite grateful for that because they have kept us going. Like, at one point we thought of giving up, but they constantly remind us like to check up on us on the progress that we have made so far, and they sent a link for GPAI, and we actually applied, and we were accepted among the teams, and we are actually getting some mentorship. So GPAI is mostly, okay, it's an initiative that bridges the gap between practical and theory on AI projects. So that's what it does. So our mentor, because it's a small world, we discovered our mentor is also here and is from Cote d'Ivoire, so he's also attending this Indaba 2024. And that's the other progress that we have managed to make so far. So we're still undergoing mentorship through Ismail Khan and the other members. And in terms of the lessons that we've managed to learn so far, I think one of the biggest lessons is being consistent. At first, we would meet like maybe twice a month virtually because we're all in different countries. So we have managed to be consistent in our meetings. Either we are just chatting on app, or we do some calls to just check up on the progress, because Billy is the one who's on the ground concerning the developments of the project. So we constantly have those meetings. And also the other thing that we have managed to learn through this whole ideathon is time management. We have discovered that in order for you to complete a project, you have to have good time management skills and be able to set aside maybe a time frame for a certain for the project to be completed. So those are some of the other things that we have managed to learn through this ideathon.
Yeah, and also what we've learned during the period of time that we've been working together is that also it's important to leave room for negative stuff that might happen. Because I remember the first time we deployed the cameras, even if they were waterproof, but the next day they were damaged, and we bought them quite expensive. So that was quite draining. But at the end of the day, we managed to buy other cameras, and we proceeded with the project. So I think leaving room also for other things that might come is also important to foster forth the project that we're working on.
Okay, so many thanks to Deep Learning Indaba for awarding us this opportunity, to the Ideathon team. You are doing a good job, and thank you so much. And also for the credits that we got from Google, thank you. And also the mentorship that we're getting from GPAI, I think is directing us in the right direction towards the goals of our project.
Sure, and also for many thanks also to the Zambia Research and Development Center for buying the materials that we needed, and they actually promised us to say if everything works well with whatever we are doing, they are ready to actually pump in some good money so that we can push forward the project. And also for OpenAI, because they gave us access, I think all the attendance last year to actually use ChatGPT, the new version. So thank you to them as well.
Thank you very much for sharing such valuable experience. So I think we have time for 2 short questions.
Hello, congratulations for your project. I have a question, or 2 questions. In your team, do you have any manager in your team, or is only mentorship you have? And also, how did you manage to split tasks between you, and also did you have someone who know a bit about project project management, or no? That is, thank you.
Okay, thank you. So if I got you well, the first question you were asking if we have a manager, you said, okay. So in our team, what we did, we have a team lead, and we have assigned roles for every one of us. So yes, so whenever someone cannot fulfill their role, there is always the next person to assist. But however, at the moment, because the setup is in Zambia, here Billy is the only one now who's available to be able to see what's happening with the project. So he gives us the updates, he sends videos, and then we can do other tasks in between virtually. And then the second question, you were talking of project management. Okay, so because of the different backgrounds of the team members, we do have what you are talking about from other members, and also I think because of the guidance that you are getting from the mentorship, it's actually assisting us, because you find that you might not know everything, but as you progress, you get to learn something, and you get to also correct other things that you thought maybe were supposed to be implemented in the project. So that's still an ongoing process for us. I hope you're answered.
Thank you very much. One last question. Yeah, there is one there, over there. Over there.
Hello, thank you for sharing your project, your idea. I would like just to know, like I see there is a few country in your teams, so I would like to know, are you looking in the next years, are you looking to other people in other country like to join the activities, and also how will it will be going to for the registration? Thank you.
Yeah, I think that's a good question. Absolutely, yes. Because currently in Zambia we have just two types of fish that we are actually monitoring. That is Kariba bream and also Tanganyika bream, which is tilapia. But we want also to extend to other countries and see if we can also handle other types of species for the fish. So I think it would be ideal.
Okay, maybe just to add on as well. In Zimbabwe also we did like a small survey, and we are yet to partner with a local university in Zimbabwe. They are also doing fish research, and for now they are offering tilapia, and we were also looking into spreading it to different countries to broaden it widely. Yeah.
Thank you very much. Let's have another round of applause for the presenters. Thank you, Daphne. Thank you, Billy Peter. Also, another round of applause to Fulaser and Mansurat. Thank you for sharing such valuable experience. I'm sure that this year's participants learned a lot. Also, thank you for engagement with the presenters. So we heard about last year's, we heard about the progress so far this year. Now we're going back to the present and going forward. I'm going to tell you a little bit about how we imagined the Ideathon this year, and how we're going to actually organize the activities over the few next weeks. So actually we started the year by looking at what happened so far, what we learned through these experiences. There were amazing successes, but there were also challenges. Also, we looked at how we can do more in the future. So we started the year with a few goals. We wanted to be more scalable, to allow for more participations from all the Indaba attendees, but beyond, to also provide a space for people to think more about their ideas, to make them more structured, and also give them a higher chance for success. We also, actually that's a personal goal for myself and others I know in the team, is to include more research in the Ideathon. So starting from last year, we actually had a research track and an application track. We received two ideas that are research related in the proposals. Only one of them went to the pitching stage. So we thought that maybe giving more time for people to think through after meeting at the Indaba can give more space for research ideas to arise. And also we thought of ways to actually give exposures to proposals and winners at the Indaba, but also beyond. With this in mind, we actually imagined this year a competition that is actually spanning on two phases. The first one is here, so we meet here, we form teams here. The Indaba is still an amazing platform to make connections, so we didn't want to lose that impact. But also we'll have a second phase where you have time to detail your ideas, and to have the actual competition. So let's look at how it will look like. So at the Indaba, we started already. We have a Slack channel that is open, so please join if you want to connect with other people, to hear about their proposals. We'll try to keep the Slack channel open after the Indaba as well. During this week, we already had a networking session yesterday that was amazing. Thank you for everyone who participated and shared their thoughts and interests. We're having now an ideathon presentation, but we still have a mentorship session tomorrow that will be between 4:30 and 6:30 in the afternoon. Please, for participants who are here at the Indaba, please scan this QR code so you'll be able to sign up for mentorship. This form will stay open until end of today, so we can arrange the mentorship sessions properly, and we'll give you details as soon as possible in the morning tomorrow. Also, I know this is live streamed. Please note that this activity is open only for registered Indaba attendees. Then, after the Indaba, after we sadly go to our other less exciting lives, we'll have activities during 8 weeks. Starting in the 2 first weeks, we'll give you time to submit your proposals. We'll open the proposals call today, and it will stay open a week after the Indaba. We'll send more details over email and on the Slack channel. We'll also use these 2 weeks to match teams with mentors for longer, more detailed mentorship sessions. We're thinking about 1 or 2 hours sessions that will depend on the number of teams and the number of mentors that we have. Then after that, we will have 2 more weeks to actually have the mentorship sessions, and also for you to prepare short presentations of 15 minutes in the format of a video that you will send us. So in these 15 minutes, you'll have time to detail your ideas, the what, the why, the how, to give as much detail as possible about, the way you imagine to implement it, to make it real, and to also detail everyone's role in the team. Then, in the 2 next weeks, we'll have the judges that will look at the videos, so we'll share them with the judges as soon as we receive the full set. The judges will have the 2 weeks to watch these videos offline, and then we'll have a live-streamed pitching session where the participants will have just an elevator pitch of their idea to refresh the memory of the judges, and also present it to the people who watch live. And also that will be followed by questions from the judges, and the judges, based on that, will give feedback and scores to the participants. Then we'll take the 2 weeks after that to compile feedback, collect the scores, also match prizes to winners, and finally announce the winners. So it will be packed 2 months after the Indaba. I'm a bit worried that I will miss my Indaba coma this year, but it's for a very good reason. And then, so I'll just give a little bit more details about, what are the requirements, who can participate actually. So the Ideathon is open for everyone. When I say everyone, it means everyone here, but everyone also interested in the community. We have a few requirements. So the first one is that the proposal should have a machine learning component. That means that it doesn't have to be centered on machine learning, but there needs some use of machine learning in it. It can also be centered on machine learning. It can also be research, which we would love to see. We require to have teams of at least 2 people. The reason for that is that we want diverse teams. We want teams from different countries if possible. It's not a hard requirement to have different countries in the team, but it's a recommendation. It's actually, that serves the goal of the competition to also create connections and collaborations across borders. And, as we want for the Indaba to stay the main connector between all of us, we require to have at least 2 participants at this year's Indaba. But again, that doesn't mean that no one else can participate. It's open to everyone. Again, recommendations, we said just, be creative. All ideas are welcome. Crazy ideas are the most welcome. Diverse teams, diverse not only in terms of citizenship, but also in terms of gender, in terms of backgrounds, all axes of diversity. And also that's important, and I think it's important for the feasibility of the idea and its realization, think very carefully about the distribution of the roles in the team. It's actually one of the criteria that we will ask the judges to look at. Okay, so now, how can you help if you don't want to participate? I know that many people here want to help. So depending on the number of participants, so we would love to accept everyone. We would love to hear from everyone. But if we receive 100 proposals, we don't have the bandwidth to do that. So if this is the case, we will go through a reviewing phase to select a subset of proposals that we can give enough space and support to develop well. Then for that, we are looking for reviewers or potential reviewers. We are not certain that we will call your help, but it's probable. Then we need mentors. We will have the mentorship tomorrow. So if you are still interested in that, please sign up. I will show the form, the QR code for the form next. But more importantly, we need mentors for after the Indaba. The commitment is around 1 or 2 hours, and it happens between week 2 and week 4 after the Indaba. And what is needed here is to have feedback on how clear are the ideas, how impactful they could be, and ideas on how to actually develop them further and make them stronger. So if you participated in this activity before, given that we have more time this year, we'll actually be looking more into details as well, so it'll be a little bit more demanding. We also look for judges, a little bit more commitment, but it's also very fun. The commitment is around up to, we hope, 2.5 hours of offline videos to watch on your own time over the course of two weeks. And then building on last year's experience, we expect around 3 hours of pitching sessions. And all that will happen between week 4 and week 6 after the Indaba. So keep in mind, these are estimates. It can vary a little bit, but we'll keep you posted as soon as we have the details on the numbers, both for the participants and for the judges and mentors. And what is needed, the activity itself in this case will be to watch the videos, to think about questions, to challenge the participants to actually make sure that they have the right team and the right idea to succeed in building something that is truly impactful. And then give feedback also during the session and obviously scores. So yeah, if you are interested in any of these activities, please use this form to sign up. And if you have any questions, either for these activities or for participation, please feel free to come to us, Siobhan, myself, and Daniel, who I saw over here. Yeah, we're very happy to help with any question that you can have. And last but not least, we are very happy to announce an amazing set of prizes this year. Really a huge thank you to all of our sponsors. Also, thank you to our amazing sponsorship team for making these connections possible. These prizes actually range from compute or technical infrastructure to grants to training and technical support. And really, it's suitable for startups, but also suitable for research, and gives a lot of support to make these ideas happen. So please submit a lot of proposals. It will be really great to actually use this amazing support to good causes. So yeah, that's all about the detail of the edition. And now if I can get a drum roll, please. We declare the Ideathon 2024 officially open, and you can you can start submitting your proposals now using this QR code. We'll share all the details also later on Slack, through emails, etc. So we're sure that no one misses that. But yeah, we're really waiting and looking forward to your amazing ideas as usual, and looking forward to see what this new format of engagement will lead to. Yeah, enjoy. And with that, if you have any questions now, I don't know what time is it, how much we have, but yeah. What time is it? 6:30? Okay, we can have one or two questions before we go to dinner, and we will stay available, over Slack or email as well.
Thank you. My question is it possible for a mentor or judge to participate in the proposal?
That's a very, very valid question, a very good question. You can imagine that judging is not possible, but I don't see why a mentor cannot. As long as you stay, impartial in your advice. But, the key thing is judges won't be able to participate for sure.
All right, thank you.
One last question before dinner? Yeah, we have one here.
Okay, so my question is about the number of applicants that you will get. So if you have a number of people that have already applied, let's say 100, so for the next stage, are you doing pre-selections of a number of people that are advanced into the next stage? Or for instance, let's say after today, after this week, after tomorrow's event, and there are already 100 proposal submissions, are you going to have a pre-selection before we advance to the next stage?
Yeah, thank you very much for the question. It's really a good opportunity for me to clarify that. We would love to see 100 ideas. It's really amazing. But, it's really, it's a matter of capacity as well. So in order to be able to support you properly, to give you the best chance to actually realize your ideas, if we do receive this large number, we will have to do a pre-selection. I think, it's hard to estimate exactly now, but roughly I think we can deal with around 30 proposals, but no more than that. Okay. Well, thank you very much for your interest again. It's really great to see so many people here at this time of the day. So now it's time for dinner. I won't keep you further, and thank you very much for attending this presentation. Thank you also again to all the presenters.
Babakar. Babakar.
Hello. So the session is delayed a little bit. We're just waiting for those that are still having dinner. So we're just gonna wait another few minutes if you can just bear with us. Thank you. Okay, so there's not many of us, so if you don't mind, if you can move down so we can have a little bit more of an intimate discussion, if you're okay with that.
Please come closer because this is a Q&A session now. It's question answering. There is nothing to present. It's an interactive one. So you will have the opportunity to ask questions. That's why we are here today. We need questions from you. Hello, so my name is Hatem Haddad. I'm from the Publication Committee. I'm happy to see you here because I saw your papers, I saw your emails. We had a lot of interaction with the Publication Committee. And I'm happy to see you here because that means you passed the first process of selection. For most of you, it was the first time that writing a scientific paper. I don't know if you find it easy or no. But we are here to take questions of you and to explain how this process is working and what will be the next steps. So to start, I will let my colleagues from the journal Iskai, right? Yeah. Yeah, to start because it was a long day and I will let them start to explain what is the journal and what you have to do here in Indaba Friday. And then we go back with me for the process of reviewing, selection, and what will be the next steps for your papers.
Okay, I don't need to introduce me. I think I've annoyed a lot of you, so I'm going to let them introduce themselves.
Hi, everyone. Congratulations for being here. My name is Georgina. I'm a researcher